Alright, so good night to everyone. Welcome to Moyo Math Day 5, session of Day 5. Sorry for the late start one. I know that the plan was supposed to do a marathon session today, but today I was really ill, and I'm now recovering, feeling a lot better. So I told myself that I have to do a session tonight to ensure that we can at least complete some important topics, review the key topics that we expect to see in the exam, that we normally see in the exam, and to ensure that that we are comfortable with answering those questions if we do see them tomorrow. Alright, so my apologies for the late start, and let's see what we can get done tonight. Just know that I'm not going to stay very long tonight because I'm not 100%. Alright, but just wishing everyone all success in the exam tomorrow. Remember, use tonight to try to prepare key topics that you will see in the exam. Ensure that you're ready for those topics. Your functions, your statistics, your circle theorems, your bearings, your matrices, vectors, transformations, your factorization, your trigonometry, of course measurements. So these are key topics we often see in the exam paper, and we want to ensure that we can answer them comfortably. Alright, so utilize tonight to ensure that you can review those topics and ensure that your mind is at ease, so you wouldn't go in the exam flustered, and you want to make sure that you have that relaxed spirit to take you into that exam tomorrow, so you can read the questions, feel confident about the questions, and answer them correctly, and put you in a good position to get your distinction in mathematics. Yeah. So we want to ensure that we can be in that right frame of mind as we prepare for the exam tomorrow. Alright? So I'm not 100%, but we must get something done tonight. Okay? So we're going to look at some key questions, starting with questions in relation to factorization, simultaneous. These are questions you're going to see in the early part of the paper, and we want to ensure that we can answer these questions. Today we'll be looking at as well functions. We'll be looking at coordinate geometry, making sure we can answer those questions well. We'll try to look at some statistics tonight, some linear programming. We'll also try to look at one or two questions in relation to measurements, what comes to mind. Of course, I will do questions in relation to those. Alright, if you have any questions as well too, you can send it to the chat, and I'll try my best to answer them. Alright, any topic you want me to review. So let's get into it. We have here, let's look at this. This is a question you often see in 2 of the paper. Given A is equal to -1, B is equal to 2, C is equal to -3, find the value of 1. So we know A is equal to -1, B is equal to 2, C is equal to 3. So let's ensure that we can find the value of the following expression. So it's all about us just simply replacing these variables in the expression with the numbers given. So this will be A plus B plus C. So I'm going to replace A with -1. Plus, of course, you can put -1 in brackets if you wish. I'm replacing B with 2, plus I'm replacing C with 3. Simple substitution. If you don't want to place A in brackets, that's not a problem either. So you have -1 plus 2 plus, or C is -3. So I'm going to replace C with -3, but because we have these two signs, they coincide as such, I make sure -3 is in brackets. Okay? This becomes -1 plus 2. A plus by a minus is a -3. So -1 plus 2 is 1. And 1 minus 3 will give us -2. So simple substitution of numbers for the variables in the expression given. So that's 1. 2, we have b squared, subtract c squared. So I'm going to replace b with 2, in brackets squared, subtract, and replacing c with negative 3, in brackets squared. Of course, 2 squared will be 2 by 2, which is 4. What we're not going to do here, we're not going to say minus by minus is a plus. Students often make that mistake. Remember, you're going to hold your subtraction sign. You're going to square negative 3, so that's negative 3 by negative 3. So we treat with that first. So this becomes 4 subtract 9, and 4 subtract 9 will give us negative 5. Alright? Let's look at B. So in showing that question 2, we're comfortable with question 2 of the exam paper. So we're looking at B. So let me erase. Write the following phrases as algebraic expressions. So B part 1. 7 times the sum of x and y. So this is sum of x and y, that is x plus y. So you want to convert the algebraic phrase, well, the phrase into an algebraic expression. So you have 7 times the sum of x and y. So this is the sum of x and y. And 7 times, you know, times means to multiply. So if I'm multiplying 7 by x plus y, I must ensure x plus y is in brackets. So I have 7 and x plus y in brackets, yeah? Which shows 7 times x plus y. Let's look at 2. The product of 2 consecutive numbers when the smaller number is y. So product means to multiply. We have 2 consecutive numbers. And when we talk about consecutive numbers, we're talking about numbers that, of course, you know, they increase by 1. So they have counted numbers. 1, 2, 3, 4, 5. These are all consecutive numbers. Increase by 1, counted numbers. And they want the product of 2 consecutive numbers where the smaller number is y. Now, we move from 1 to the next by adding 1, adding 1, adding 1, adding 1. So if we have the product of 2 consecutive numbers where the smaller number is y, if the smaller number is y, then the number that comes after that we have to add 1 because they are consecutive numbers. So therefore I'm going to add 1 to y. So the number after y, just after y, will be y plus 1. So the 2 numbers I have are y, which is smaller, and of course the number after coming immediately after y will be y plus 1. And we want the product of those 2 numbers. So product means to multiply. So it's going to be y times y plus 1. Yes, that's the product of 2 consecutive numbers where the smaller number is y. So this is just smaller number. The number after that is y plus 1. We find the product of those 2. Yeah? Let's look at C. So they want us to solve a pair of simultaneous equations. So again, look out for questions like these, substitution of numbers into variables, and of course, converting phrases into algebraic expression. Now, we see that in the early part of the paper, question 2, simultaneous equations, factorization. These 2 certainly you can see in the exam tomorrow. Look at the history of your papers. Every year you see factorization. You're asked to factorize expressions. You're asked to solve a pair of equations simultaneously. So let's look at it. So we have here, we want us to solve a pair of simultaneous equations. We have 2x plus y is equal to 7. We have x minus 2y is equal to 1. And let's solve the pair of equations simultaneously. So we know what we're going to do. We can solve the pair of equations simultaneously for x and y. That's the objective, to find x and y, by using a method of elimination or a method of substitution, any one of the 2. Most students like the elimination method, so students will go for the elimination method. So you want to eliminate one variable to solve for the other, and then you'll come back and solve for the first one you eliminated. So if you want to eliminate x first, you want to make sure first that the numbers in front of x are the same, because when two things are the same, you can eliminate them by subtracting. So if I want to eliminate x, I want to make sure that my terms involving x are the same, and to do so I must make sure the numbers in front of x are the same, so I can eliminate my term involving x. So the first thing when we are solving a pair of equations simultaneously using the elimination method or even substitution method, you label 1, 2. I want to eliminate x, so I have to make sure the numbers in front of x are the same. So let me make both numbers in front of x 2. This is already 2, so I don't want that to change. So I'll multiply equation 1 by 1 because I want this to remain as 2. I want my x here, I want the number in front of this x to become 2. So to allow that to happen, I multiply equation 2 by 2. So multiplying equation 1 by 1, we're going to get 2x plus y is equal to 7. Every term in the equation, you're going to multiply by 1. And I'll call this equation 3. Because what's going to happen here, I'm going to get two new equations, but the terms involving x are the same. Let me multiply equation 2 by 2, x by 2 will be 2x. Negative 2y by 2 is negative 4y. 1 by 2 is 2, and this is equation 4. And what we want to do now is to eliminate our terms involving x. We can do so now comfortably by subtracting my two equations. So when I subtract these two equations, look at what's going to happen. What I like to do is to follow through with the subtraction sign between my terms. So between my terms involving x, I like to see the subtraction sign between it, showing you subtracting these two terms. Between my terms involving y, I like to put my subtraction sign between them so you can see where you are subtracting your terms involving y. And between my constants, I like to put the subtraction sign so you can actually see the subtraction of the two constants. So this will be 2x subtract 2x is 0. Yeah? What we see here, I'll always advise what you see here vertically, write it down horizontally. So just as you see here, you're going to write it horizontally. As you see here vertically, let's write it horizontally. This will be y, positive y is the same as y, subtract negative 4y, and I'm going to put negative 4y in brackets, is equal to 7, so just as I see it here vertically, I'm going to write it horizontally, 7 subtract 2. So we're going to get here y, a minus by minus is a plus 4y is equal to 7 subtract 2. Y plus 4y will give us 5y. 7 subtract 2 is 5. And what I can do now is to divide both sides by 5. So I can make y the subject. So I'm dividing 5y by 5. 5 divided by 5, and therefore y is equal to 1. But remember, when you're solving a pair of equations simultaneously, you're solving for both x and y. So let's make sure we can solve our simultaneous equations, right? Because like I said, you can see it where they'll bring a pair of equations to solve by itself, or they can bring it in a problem solving type format. Alright? So we look at one of those also. So when y is equal to 1, I'm going to substitute now y equal to 1 into any of the original equations so we can find x. So I'm going to substitute y equal to 1 into any one of the original equations. You pick one, it doesn't matter, you get the same result for x. I'll put it into equation 1. So equation 1 is 2x plus y is equal to 7. And where I see y in equation 1, I'm going to replace it with 1. So this is 2x plus 1 is equal to 7. And now let me proceed to make x a subject. So I'm going to subtract 1 from both sides. So I'm going to get 2x is equal to 7, subtract 1. I'm going to get 2x is equal to 6. And therefore I divide both sides by 2. And I'm going to get x is equal to 3. Alright? So making sure we can solve a pair of linear equations simultaneously. Alright? So this is a pair of linear. Two lines cross, they meet at a point, and you're solving for the coordinates of the point of intersection. Alright? What you would have done, I think 2 nights ago, we would have learned how to solve the linear and the non-linear. So if you look at that video, I think it was session 3. You'll see where I did solving a linear and non-linear. So this is solving a pair of linear equations. Two lines cross and meet at a point. So the value of x, and therefore x is equal to 3 and y is equal to 1. So making sure we can solve our pair of equations simultaneously, alright, using elimination or substitution. So let's look at D. Making sure we remember how to factorize. You're going to see, I'm certain about it, they'll ask you to factorize expressions in that exam tomorrow. And let's make sure we can factorize, okay? So, I'm going to erase. So, you want to make sure we can factorize, and in order for us to factorize, you have to be able to recognize the methods of factorization, right? So, just keep in mind what are the methods of factorization. You have the methods of factorization. You have, one is the HCF method, the highest common factor method. 2 is the grouping method. So you have the method of grouping, and this is normally recognized when you have 4 terms in the expression. 3 will be the difference of 2 perfect squares. And the 4th method is the method of the quadratic expression. The quadratic expression normally looks like this: ax squared plus bx plus c. So those are 4 methods of factorization you must familiarize yourselves with. And sometimes you will get questions where you ask to simplify an expression, but in order for you to simplify it, you have to use factorization. So I'll try to do a question in relation to that as well. Alright? But let's make sure we can factorize, and then we look at some questions where factorization can come into play to help us simplify expressions, and of course with a simultaneous where you're given a scenario and you create a pair of equations and you have to solve them simultaneously. Alright? So, looking at D, we want to factorize 4y squared minus c squared. Of the 4 methods, the method of factorization we're going to use for this is the difference of 2 perfect squares. Now, why 4y squared is a perfect square? 4y squared can be expressed as a product of the same 2 factors. 2y by 2y, that's why it's a perfect square. 2y by 2y gives us 4y squared. Z squared is also a perfect square. This can be expressed as a product of the same 2 factors, z by z. So this is when you, and of course the subtraction sign between them represents the difference of 2 perfect squares. So just looking at the expression, it corresponds with the name. And to factorize this one, we put 2 sets of brackets. In my brackets, the first term will be the factors of 4y squared. So in this first bracket, I'm going to put 2y. In this bracket here, the first term I'm going to put is 2y. In this bracket, the second term I'm going to put the z. In this bracket, the second term I'm going to put the z, and I always separate with a positive sign in one and a negative sign in the other. And it doesn't matter the order, it can be negative, positive. Alright? You can put negative here, positive here, but make sure there's a plus in one and a minus in the other. So this is the difference of two perfect squares. We are asked to factorize 2ax minus 2ay minus bx plus by. This here is an expression we are asked to factorize, and the method we're going to use here is the method of grouping because we have 1, 2, 3, 4 terms. So let's make sure we can factorize that expression. So I am going to divide this expression into two pairs. And I'm going to factorize using the highest common factor each pair. This is one pair, this is another pair. So I'm going to factorize using the highest common factor method. I'm going to factorize each pair. So what is the highest common factor in this first pair? Clearly 2 and a. You can take out 2a as the highest common factor there. And let's divide 2a into each term. 2a into 2ax will give us what? 2 into 2 is 2 into 2 is 1 times a into a is 1 and x remains. 1 by x will give you x. That's divided 2a into 2ax. 2 into 2 is 1, a into itself is 1 and x remains. Keeping in mind there's a multiplication sign in between 2a and x. That's why I placed the multiplication sign there, right? So we can see what goes in our bracket. Let's divide 2a into negative 2ax. A minus divided by a plus is a minus. I treated my signs first. 2 into 2 is 1 times a into a is 1 times what remains? Y. 1 by y is y. So I factorize my first pair using the highest common factor method. Let me factorize my second pair. Always remember when you're factorizing the second pair, the sign controlling the first term of the second pair, you have to write that. That's the first thing you're going to write. Okay? So this will automatically be a part of the highest common factor, automatically. Whether it's a negative sign or a positive sign, make sure you write that sign first. And what else is common here? Clearly, if you look, b is common to both. So negative b becomes my highest common factor. So let me divide negative b into negative bx. A minus divided by minus is a plus. B into b is 1 and x remains. 1 by x is x. Let me divide negative b into positive by. A plus divided by a minus is a minus. B into b is 1 and y remains. 1 by y is y. So when I factorize each pair, what must happen? I must have the same expression in brackets, same term, same signs. This is when you know you're on the right track with factorizing using the method of grouping. So what you're going to do is take out x minus y as a common factor. Because it's common to both, you take it out as a factor. This is one easy way of getting the final representation. You take out x minus y as a common factor. And what remains, which is the 2a and negative b, you place in the other bracket. And it doesn't matter the order. You can have 2a minus b first, x minus y after. So you divide it into two pairs, factorize each pair, must get the same expression after you factorize each pair in brackets. And therefore, to get the final answer, you take out x minus y, which is common to both, and your 2a minus b, you simply place in the other bracket. Alright? And remember, when you're asked to factorize, you have to take this expression and represent it as a product of factors. That's factorization. Alright? Let's look at the third. 3x squared plus 10x minus 8. We want to factorize that. So the method we're going to use is the method of the quadratic expression, because a quadratic expression is of this form. ax squared plus bx plus c. So this looks like that. So we're going to multiply. When you're multiplying using that method, you always multiply a by c first. So you're going to multiply a by c. So a by c you're going to multiply. Yeah? So A will be my 3 and C will be negative 8. Now 3 by negative 8 will give me negative 24. Now I want two factors of negative 24 when multiplied will give you negative 24, but when added or subtracted can help you to get the middle term 10x. And my two factors of negative 24 will be plus 12 by negative 2. So plus 12 by negative 2 gives me negative 24, but look at what's going to happen. If I take plus 12, attach x to it, and I take negative 2, attach x to it, 12x subtract 2x gives me the middle term 10x. And once I arrive at the middle term, I know I'm on the right track, and what I'm going to do now is convert these 3 terms into 4 terms, just like these 4 up here, and I will use the method of grouping, which is what I did up here, to get my final answer, representing my expression as a product of factors. So let me convert these 3 terms into 4 terms. I'm going to write 3x squared. I'm replacing plus 10x with plus 12x minus 2x minus 8. I'm going to factorize now using grouping because I have 1, 2, 3, 4 terms. So I'm going to divide it into 2 pairs. And let me factorize each pair. What is common to my first pair? Clearly 3. Because 3 can divide into itself. That's the highest common factor to itself and 12. So you pull out 3, which is the highest common factor there. Likewise, x is common to both. Yeah? You have x squared, you have x to the power 1. Remember, you always take out that common variable with the lower power. So if you have to pull out the highest common factor of x, you pull out x with the lower power. So that is x to the power 1, right? So take out x to the power 1x. So 3x becomes the highest common factor, which you're going to divide onto each term. So 3 into 3 is 1 times x into x. What is x? 1 by x is x. Let me divide 3x into plus 12x now. A plus divided by a plus is a plus. 3 into 12 is 4 times x into x is 1. 4 by 1 is 4. So I factorize my first pair using the highest common factor. This first pair you have to factorize using the highest common factor method. Let me factorize my second pair. Always remember the sign controlling the first term of the second pair. You make sure you write that down, so that will automatically be a part of your highest common factor. What else is common here? Clearly 2 is common to itself and 8. The 2 is the highest common factor to itself and 8. So I'll take out 2 and therefore negative 2 becomes the highest common factor. So I put my brackets. Remember, when you're factorizing, you always show us a product of factors, so hence you must have your brackets. So let me divide negative 2 into negative 2x. Negative 2 into negative 2 is 1, and x remains. 1 by x is x. And divide negative 2 into negative 8. A minus divided by a minus is a plus. 2 into 8 is 4. So I have x plus 4, which is common to both, and I have the same thing in brackets, so you know you're doing this thing right, so it's common to both. So therefore your final step now will be to take out x plus 4 as a common factor, and what remains is 3x and negative 2 you can place in the other bracket. So you have x plus 4, 3x minus 2, and again it doesn't matter the order. If you want to put 3x minus 2 first, x plus 4 after, it doesn't matter the order, alright? So this is factorizing these 3 very important expressions. So please make sure we know how to factorize and we know the methods of factorization, alright? So let's look at this here, where we are asked to simplify that expression, but factorization will come into play. So let's make sure we can pay attention to these type of questions where you're asked to simplify, but to simplify you have to factorize. So let's get this here. So you want us to simplify x squared plus 7x all over x squared minus 49. Now when students see that and they ask to simplify that, what students will think of doing automatically is dividing this x squared into that x squared and this 7 into that 49. And that can't be done. Alright, once there's an addition or subtraction sign separating terms in the numerator or denominator, note you cannot divide one term into the other. Alright? Once an addition or subtraction sign separate your terms, you cannot divide the term in the numerator into your term in the denominator or vice versa. You can't do that. So how are we going to factorize, how are we going to simplify this expression? To simplify that expression, this is where factorization will come into play. That is, I'm going to factorize my numerator, and the method of factorization I'm going to use here is the method of the highest common factor. It can't be grouping, I don't have 4 terms. It can't be the quadratic, it's not of the form ax squared plus bx plus c. It can't be the difference of 2 perfect squares. I do not have one perfect square, but the other is not. And there's a plus sign separating them. So it can't be the difference of 2 perfect squares. So the only method is the highest common factor method. So if I look x is common to both, I will take on as my common factor x with a lower power. X in the power of 1. Nothing else is common. Let me divide. X in the power of 1 into x squared gives me x. X in the power of 1 into plus 7x gives me plus 7. That's me factorizing the numerator. Let me factorize the denominator. So what method of factorization I'm going to apply here? When I look at that, I see where x squared is a perfect square, 49 is a perfect square, and the subtraction sign between them represents the difference of 2 perfect squares. So make sure you know your method, right? So this is, of course, the factorizing x by x, 7 by 7. So I'm going to put 2 sets of brackets. I'm going to take factors of x squared, place it because x squared leads. I'm going to put the factors of x squared first, and I'm going to then put the factors of 49 after. And then I'm going to separate a positive in one, negative in the other. And of course I can simplify that by, now I can simplify by dividing what is in the denominator into the numerator, because you can only divide what is in the numerator into the denominator if you're multiplying. You see, this is addition or subtraction sign separating terms. You can't divide the denominator into the numerator or numerator into the denominator. That cannot be done. If you're multiplying, this is x times x plus 7. This is x plus 7 times x minus 1. So now I can say x plus 7 into x plus 7. Now I can divide those two into each other because I have the product, yeah, in both numerator and denominator. Yeah, and therefore I'm going to be left with x all over x minus 7. That's the answer for that part. Alright, let's look at B. So they like to realize that they bring a lot of indices. So B, of course, we have to know your laws of indices, the law of multiplication, the law of division, the law of the zero index. When the power is negative, what you do. When the power is a fraction, what you do. Right? So if we have find the value and how to solve equations in index form. This is one such. Find the value of r when x squared times x to the power of 6 is equal to x to the power of r. So we want to solve this equation in index form. Index form because I have a base and power. So once it's index form, you have a base and power, right? And this is an equation in index form. You have different types of equations you have to know how to solve. Simple equations, simultaneous equations, quadratic equations, equations in index form. This is an example of such. So how do you solve an equation in index form? You want to try your best to get single terms with the same base on either side of the equal sign. This is your base, that's your power. So I have one term on the right to a base of x to a power of r, and I want to also make sure on the left I have one term to a base x and a power. So always try to get single terms on either side of the equal sign of the same base. So I can simplify this from two terms, two quantities, to one, yeah, by simply applying my law of multiplication of indices, which is once you have the same base, you're multiplying, and you have the same base, when these are called the base, once I have the same base, then I'm going to maintain that base and the powers I add. That's the law of multiplication. So you're going to get x to the power of 8 is equal to x to the power of r, and therefore I can say r is equal to 8. Once the base are the same, so have single terms of the same base, what you're going to do now is just equate the powers. So let me write here in words for an equal base. We equate the powers. So I'm going to put r equal to 8. So the value of r there is 8. So this is solving an equation in index form. So get accustomed to this and make sure you know your laws of indices, alright? Look, we have another equation here, right? They want us to solve an equation. Find the value of s when s to the power of 3 is equal to 8. Alright, so s to the power of 3 is equal to 8. So how am I going to find s? So there are two ways in which you can find s here. Two ways, right? The first is when you have a variable raised to a power and you want to remove that power, in this case it's a power of 3, what you can do is find, in this case, to remove this power of 3, I must find the cube root of each side. Now many of us are familiar with square root. If you have x squared is equal to 4, you're familiar with that, power of 2, custom using a power of 2. So you know to remove a power of 2, you'll find square root of both sides. You know that. So when you find the square root of x squared, this power of 2 disappears and becomes x, and the square root of 4 is 2. The same concept you're applying here. You want to remove a power of 3. So you're not going to find the square root, you're going to find the cube root. That is, 3 is understood as the order of the root symbol. 2 is understood as the order of this root symbol, hence the reason we say square root. Even though the 2 is not seen, it's understood. So to remove this power of 3, I'm going to find the cube root of both sides. What I do to one side, I do to the other. And the cube root of s cube allows the power of 3 by my s there to disappear. So it becomes s alone. And the cube root of 8, you can go to your calculator, work out the cube root of 8 again 2. So that's one way. The other approach is this, or s cubed is equal to 8. You can express 8 as a base and power. 8 is the same as 2 to the power of 3. Yeah? And when the powers are the same, for the same powers, we equate the base. So that's what we're going to say here. For an equal power, or for equal powers, we equate the base. So you're going to put s is equal to 2. So two ways of getting the same result. Yeah, so make sure you know how to treat with those equations in index form. Right, let's look at this. And this is a case where, you know, we have I think I missed out another part. I think I missed out part of this question. I missed out the part 2, but that's alright. What I'll do, I will show, they ask me to show, so I'll show where this equation, but when they ask you to show something in mathematics, you want to show by working that this equation can be obtained from this triangle. Yeah? So I'll show you how we obtain that equation from that triangle. And in part 2 of this question, this was from 2024, they asked you to show, they gave the equation to show the equation that can be created from that shape also, which is a quadrilateral. Alright, so I left out part 2 when I was putting it together. So what I'll do is I'll just simply show you how we can get the equation from the quadrilateral, and then they will want us to solve them simultaneously. Right? So you have part 1, part 2, and we want to solve them simultaneously. Right? Solve the pair of equations in 1 and 2 to find the values of A and B. So let's show how from this triangle, for the triangle, show that 2a plus 5b is equal to 171. So let's show for the triangle why that is the case. And then we'll show for the quadrilateral what is the equation we're going to obtain from the quadrilateral. Alright? So for the triangle, so get familiar with questions like these, right? So of course, to get that equation from the triangle, you know that these are 3 angles in that triangle. And you know that the sum of 3 interior angles of a triangle is equal to 180 degrees. So all you have to do to show this in part 1 is to add all 3 angles, A plus 2B plus 3B plus A plus 9, and we're going to put that equal to 180. Of course, we're going to simplify what is on the left, so I'm going to group like terms. So this will be A plus 2B plus 3B plus 9 is equal to 180. And we know A plus A will be 2A plus 5B is equal to 180 subtract 9. And that will simply become 2A plus 5B is equal to 171. And because they asked you to show, then we are going to write at the end, hence shown. Anytime in mathematics they ask you to show something, when you show it, you've shown that that is the case, yeah, you always write hence shown. Alright? Similarly, there was a part 2 where we had to, for the quadrilateral, show what is the equation. Let's show what the equation is, and the same concept applies. So for part 2, that is a quadrilateral. And always make sure we know how to find the sum of interior angles of the quad. That's very important, of a polygon. Because we do a question where you know, what us to ensure that we're clear on that. When you have any polygon, that's a figure with many sides, starting from a triangle, quadrilateral, 5-sided figure, pentagon, 6-sided figure, hexagon, and so on, right? Note, you can find the sum of interior angles using an important formula. Yeah? And that formula is, you should know this formula to get the sum of interior angles. So sum of interior angles, I just write it here. Sum of interior angles of a polygon, that's a figure with many sides. S is equal to n minus 2 times 180 degrees. So you know if it's 3 sides, n is the number of sides, right? N is the number of sides. Make sure you know that formula, right? Make sure you remember that formula. Especially if you have any polygon and you have to find the sum of interior angles. Alright, how many all interior angles must add to give what? What will be the sum of all interior angles? So if you have 3 sides here, 3 subtract 2 is 1. 1 by 180 is 180. That's why the sum of interior angles is 180. You have 1, 2, 3, 4 sides. 4 subtract 2 is 2. 2 by 180 is 360. So you know that the sum of interior angles of this quadrilateral is 360, and therefore you can say 6a plus 3a plus 2b plus 18 plus 3b plus 3b minus 2a, that is equal to 360. Yeah, the sum of interior angles. So let me simplify, let me group like terms. This will be 6a plus 3a plus 3b plus 3b. Well, let me group all my terms involved in it. So 3a, 6a plus 3a minus 2a plus 2b plus 3b plus 3b. And of course, I'm going to subtract 18 from both sides. So this will be 360 subtract 18. So when I simplify, what am I going to get? 6a plus 3a is 9a, and 9a minus 2a is 7a. This is 2b plus 3b is 5b, and 5b plus 3b will give us plus 8b. And of course, that will be 360 subtract 180, subtract 18, sorry, and that will give us 342. Yeah. Okay. Yeah, 342. So this here would be, of course, for the second part, they asked us to show as well that the equation obtained from that quadrilateral is this. So we can also state hence show. So I like to talk when I was putting together the PowerPoint. So what we want to do in this next part of the question is solve simultaneous. Knowledge of simultaneous equations must come into play, and you have to know how to solve them simultaneously to find A and B. So just do that quickly, and then I'll show, see that we on this S is equal to n minus 2 times 180. I want to show a question where you know that can come into play. You can see that in the exam tomorrow. It's highly possible. A polygon, and make sure you know how to treat with such. And then we look at some coordinate geometry. We look at some functions. All right, very important coordinate geometry. Functions. So let us solve simultaneously the pair of equations. So I'm erasing this. So this will be 2a plus 5b is equal to 171. This is 7a plus 8b is equal to 342. And we want to solve them simultaneously using the method of elimination. So I'm using elimination, right? So the first step is to label 1, 2, and then we want to eliminate, let's eliminate our terms involving A. First, right? I like to eliminate the first term. So A. So to eliminate A, I want to make sure that my terms involving A are the same, which means I have to make sure these numbers in front of A are the same. They're not the same right now. So only when two things are the same, then can you eliminate them. So let me make both numbers in front of A the same. So the highest or the lowest common multiple, of 2 and 7 is 14. So let me make both numbers in front of A 14. So I'm multiplying equation 1 by 7, and I'm going to multiply equation 2 by 2. So I'm going to get two new equations where the numbers in front of A will be the same. 2a by 7 is 14a plus 35b, and let me multiply 171 by 7. which is 1197. I'm going to call that equation 3. Let me multiply equation 2 by 2. I'm going to get 14a plus 16b is equal to 342 by 2, which is 684. Equation 4. Now that my terms involving a are the same, I can subtract. And what I like to do is to put the subtraction sign between your terms, here, here, and here. So you know 14a subtract 14a is 0. Just as you see here vertically, I always advise you write it down horizontally. So this will be 35b, positive 35b is the same as 35b. Subtract positive 16b is the same as 16b. And this will be 1197 subtract 684. So we know that 35b subtract 16b will give us 19b, and 1197 subtract 684 will give us 513. And therefore, to get b as a subject, I'm going to divide both sides by 19. So when I divide 513 by 19, I'm going to get what? I'm going to get 27. So make sure you can solve a PM equation simultaneously. You don't want to see this in the exam tomorrow and get it wrong, huh? So when we get b as 27, what are we going to do? Substitute b equal to 27 into equation. We can pick any one of the equations. I'll choose equation 1. Remember, it doesn't matter, you can pick any one. So equation 1 is 2a plus 5b is equal to 171. And where I see b, I'm going to replace it with 27. So this is 2a plus 5 times 27 is equal to 171, which is 2a plus 27 by 5 is 135 is equal to 171. And what am I going to do? I'm going to now remove 135 by subtracting 135 from both sides, and then I'll divide both sides by 2 so I can get a by itself. So this will be 2a is 171 minus 135. And this is 171 minus 135, that's 36. So 2a is equal to 36, and then I'll divide both sides by 2. And therefore a is equal to 18. So the value of a is 18, therefore a is 18. And b is 27. So let's make sure, class, that we can solve our pair of equations simultaneously. Let's make sure we can factorize. When you see that in the exam tomorrow, you don't want to, see that and lose valuable marks, alright? Right, and this one here as well, we have this one here. And I can bring something like this tomorrow too, so you look at that quickly. I'll start with this, we'll do this entire thing here. And then we will move on to, right, you can see something like this. Let me erase. Alright? So this will involve, very important, we did it last night when we looked at bearings and so equation of circle theorems, and we saw when parallel lines. Now keep in mind, you can see questions tomorrow with lines being parallel, and the three important angles that are applicable to lines being parallel. Alternate, corresponding, and co-interior angles. And you want to make sure, if you do see such, how to treat with it. Alright? And the application of those important angles for lines that are parallel to achieve what is required. Okay? So, before we get into this one, let me do this quickly. We'll do that polygon and then we'll jump into some coordinate geometry and functions, which certainly you can see in the exam tomorrow. Alright? So let's look at this here. They want us to simplify. This is where laws of indices will come into play again. You see, they've been bringing a lot of indices, questions involving indices. And this here I think was a recent year. This was 2023 or 2022, one of the two, right? Simplify x to the power of 3 all squared. So if you see something like that tomorrow, then you know it's simply taking what is outside, the power outside, and you go to multiply by the power within. That's a law. So this will be x to the power of 3 times 2. Let's take the power outside and multiply by the power within. This becomes x to the power of 6. 2 y to the power of 8 divided by y to the power of negative 5. So you're applying the law of division. You have to know what's your law of division, law indices, division. Yeah, law of division of indices. So you have to know that. So this will be, this is the same as, and I like to encourage students to rewrite it like this. Y to the power of 8 over y to the power of negative 5. That's the same as division. Alright? And when you're dividing, what you want to do is maintain your base, y, and the powers. Remember, when you're dividing, you subtract the powers. When you're multiplying, you add the powers, provided the base are the same. The bases are the same. In this case, the bases are the same, so I maintain my base y. And when you're dividing, you subtract the powers. 8 subtract negative 5. Don't forget that. And the same 8 subtract, and you put that negative 5 in brackets to separate the two sides. So you're going to get y is equal to 8 plus 5, y is equal to 13. And that's your answer there. Alright? Factorize. Again, factorization. Factorize, and then simplify. Look at the expression. You're not going to say x squared and x into x squared. You're not doing that. So you have to implement factorization here to simplify that expression. So they ask us to 1 factorize xy minus y squared. Let's look at A. Again, you have to know your methods of factorization. You can't use grouping here. We don't have 4 terms. This is not the difference of 2 perfect squares. Y squared is a perfect square, yes. You have a minus sign separating them, yes. But xy is not a perfect square, so you can't use that method. It can be the quadratic expression because it's not of the form ax squared plus bx plus c. So the method of the highest common factor is what we're going to use here. And what is common? Y is common to both, but you always take out y with the lower power. Y to the power of 1. So I take that out as a factor. And when you're factorizing, you're representing the expression as a product of factors. So you make sure you put your brackets. So let's divide. Y into y is 1. And x remains. 1 by x is x. Then we divide y into negative y squared. A minus divided by a plus is a minus. Y into y squared. Remember when you're dividing, you will keep the base, and the powers you subtract. 2 subtract 1 is 1. So when you divide y into y squared, you're supposed to get y. So y into y squared gives you y. Alright? So you're dividing y into y squared. So therefore, you will keep y and subtract the powers. The rule of division. So when we factorize, this is what we're going to get. So let's look at B. You have x squared minus y squared. So to factorize that, the method we're going to use is the difference of two perfect squares. Subtraction sign represents the difference, and we have what? Of two perfect squares. So therefore, this is what? X by x, y by y. You put your two sets of factors. Because x squared leads, x will lead each bracket. And because y squared comes after, y will be written after. And you separate plus and minus. Right? So the difference of this, you see, when you see something like that, an expression like that, and you ask to factorize it, actually easy marks on the bar. Hence simplify the expression. So let's simplify xy minus y squared over x squared minus y squared. So to simplify this, you're not saying x squared into x because you have a subtraction sign separating terms in the numerator and denominator, so you cannot divide one into the other. Once there's an addition or subtraction sign separating your terms in the numerator and denominator, you cannot divide y squared into y squared, right? So you have to factorize both numerator and denominator, and you would have already done the work. You did that in part A. Look at this. You have to factorize that. So you're going to write this as y into x subtract y. And this is the difference of two perfect squares. This is x plus y, x minus y. And what can happen here now? Clearly your two x minus y's can divide into each other. Now that you have the product. So now you can easily divide the numerator into the denominator, or vice versa, denominator into numerator. Those two divide into each other to give 1. And you're left with y all over x plus y. That is your answer. So get familiar with those types of expressions to simplify where factorization is involved. Alright? Right. So you can see questions like this, right? And these questions now will involve the product of binomials. You know what the product of binomials? If I have, for example, x plus 2 by x minus 3, I have to multiply those two. Or we multiply them. Yeah? So very important understanding how to multiply product of binomials. You multiply x by x, you take an x in the first, by each in the second, x by x, then x by negative 3, then positive 2 by x, then positive 2 by negative 3. That's how you're going to expand that. Alright? And that concept will come into play here. Let's look at it. It says here the diagram below shows two rectangles M and N with their dimensions expressed in terms of x. So the dimensions are expressed in terms of x, alright? So you have this rectangle M, you have the dimension x minus 3, 3x plus 4. You have this rectangle N, the dimension x plus 2, x minus 3. Good? So, given that the difference between the areas of the two rectangles, when you subtract the areas of the two rectangles, you're going to get 64. They wanted to show that, and again, show, when you're asking math, to show something, you want to go and show that the difference of the two areas, which is 64, can simplify to this. to x squared minus 2x minus 35 is equal to 0. Show that the difference between the two areas. So you have two rectangles. This is one. M x minus 3, 3x plus 4, and you have n x plus 2, x minus 3. Good? And it says here that given the difference between the areas, so the area of M subtract the area of N is 64, is equal to 64 centimeters squared. So the difference of the areas is 64 centimeters squared. They want us to show that this, and it's an equation, that this equation can be simplified to x squared minus 2x minus 35 is equal to 0. And let's show that, right? Let's see that kind of code. So, the area of M, this is M, and the area of this rectangle, the area of a rectangle is a length by width. So you're going to take your length, which is 3x plus 4, by your width, which is x minus 3. Alright? Subtract. And be very careful, because it's a subtraction sign, be very careful. The area of n. So I'm going to put the area of n in brackets. Because I have a subtraction sign here, right? Once a subtraction sign is in front of an expression with two or more terms, for example, if you have a subtraction sign in front of x, so you have to put a subtraction sign in front of 3x plus 4. It's important to put 3x plus 4 in brackets. Once you have an expression with two or more terms, make sure, and you have a subtraction sign in front of it, make sure those two or more terms are placed in brackets. Hence, the area of n, because if you don't do that, then you're going to end up in problems. This part is very important, right? The area of n, this will be your length by your width. So I put that in brackets to separate it from this subtraction sign here, is equal to 64. So we want to take this equation now and simplify, break it down to this x squared minus 2x minus 35 is equal to 0. Let's show that this is equal to that. So you have to show it. And of course, when you show something, your right hand shown after you have shown it. So let's multiply these two binomials and get familiar, because you can see this probably in the exam tomorrow. You can ask you to expand two binomials here. And let's make sure we can expand two binomials. This is what? 3x by x. You're not saying 3x by x and 4 by minus 3. Students make that mistake. You're saying 3x by each one inside of the bracket. So 3x by x and 3x by negative 3. So 3x by x will be 3x squared. And 3x by negative 3 is negative 9x. That's multiplying 3x by each in the second. Now let's multiply 4 by each in the second now. So plus 4 by x and plus 4 by negative 3. Plus 4 by x will be plus 4x. And plus 4 by negative 3 will be negative 12. Then, let me expand what I have inside of my square brackets here. And of course, you have your subtraction sign. But remember, you're separating that expression from your subtraction sign. So you make sure that this expression, after you expand it, is within brackets, separated from your subtraction sign. If you have an addition sign, you can get away with it. Does not, if brackets it's not there, you can get away with an addition sign. But once it's a subtraction sign, separate the expression with brackets, alright, from the subtraction sign. And you will just see why. So let's expand. This is what? This is the area of n. You're multiplying x by x minus 3, then plus 2 by x minus 3. Not x by x and negative 2 by 3, that's it. No. So you're saying x by x by negative 3. That's how you expand. X by x is x squared. X by negative 3 will be negative 3x. Then you're going to multiply plus 2 by x plus 2 by negative 3. So plus 2 by each of the second brackets. Plus 2 by x will be plus 2x. Plus 2 by negative 3 is negative 6. Is equal to 64. So now, let's further simplify. Let's remove this bracket now. Now I can remove this bracket so I can group like terms. And I have to now take the subtraction sign outside and multiply by each term within to remove my brackets. Good? Yes, you must separate. Once there's a subtraction sign, you have an expression with 2 or more terms. Make sure the expression is placed within brackets, separated from your subtraction sign. So this becomes what? 3x squared minus 9x plus 4x minus 12. Let me remove my brackets now. A minus by a plus, plus sign is in front of x squared, is a minus. So we get minus x squared. Then we multiply negative by negative 3x. A minus by a minus is a what? Plus 3x. Let me multiply negative. You see how these signs are changing? If you did not have brackets, then these signs will remain the same, and therefore you get your answer wrong. Placing it in brackets, you see where the signs of the terms are changing now. A minus by a plus 2x is minus 2x. And a minus by a minus is a plus 6. Is equal to 64. So what we're going to do now, let's group all like terms. I'm going to put 3x squared minus x squared minus 9x plus 4x. Let's group all the like terms together. Plus 3x minus 2x. So putting all my terms involving x together. And all my constants, right? Let me put them together. Negative 12 plus 6 is equal to 64. So let's simplify. So 3x minus x squared is 3x squared, sorry, minus x squared is 2x squared. Negative 9x plus 4x will be negative 5x. Negative 5x plus 3x will be negative 2x. And negative 2x subtract 2x will be negative 4x. So negative 9x plus 4x is negative 5x. You can put it in a calculator, we're not sure, say negative 9 plus 4 is negative 5, so you get negative 5x. Then negative 5 plus 3 is negative 2, so you get negative 2x. And then negative 2 subtract 2 is negative 4, so you get negative 4x. Just put it in a calculator, we're not sure. And negative 12 plus 6 is negative 6 is equal to 64. Yeah? And then what we're going to do, this is a quadratic equation. So let me take the 64 and a quadratic equation. Remember, you have variable squared equal sign, but the expression must be made equal to 0. So let me take the 64 I have on the right and bring it over on the left hand side, right? So when I move from the right to the left, the sign changes. So you minus 64 from both sides if you like to use the balancing method. So this will become what? 2x squared minus 4x minus 6x plus 64 comes across to the left as minus 64 is equal to 0. So we simplify that now, we're going to get what? This becomes (2x squared minus 4x). Negative 6 subtract 64 is negative 17 is equal to 0. So you may look at that and say, but that's not what they want us to show. X squared minus 2x minus 35 is equal to 0. No, you can't get it in that form because easy. A quadratic equation can be simplified. once there is something common to each term, it can be simplified. If you look, 2 can divide into each one of these. You can divide 2, so we divide by 2. If I'm dividing each term by 2 in that quadratic equation, look at what's going to happen. 2x squared divided by 2 gives me x squared. So I'm dividing each term by 2, right? If I write it like this, you can see it. 2x squared minus 4x minus 17. 2x squared over 2. Each term are divided by 2. So you divide it by 2. 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. So you get x squared, you have negative 2x now. And negative 70 divided by 2 is negative 35. And 0 divided by 2 is what? 0. So, what have we done? We have shown that the difference of the areas, which is equal to 64 cm squared, can be simplified to give us that quadratic equation, and at the end we can state hence shown. Alright, so get familiar with questions like these and get familiar with the product of binomials, multiplying these two binomials. Get familiar with if you have a negative sign and you have to separate an expression from that negative sign. Make sure the entire expression is placed within brackets. Because when you remove the brackets, the signs will change, which will then put you in a good position to get the right answer. If you have no brackets, then the signs remain the same and therefore you will not get what they ask you to show. Alright? So make sure we pay attention to those details. Alright? Okay, okay, let us okay, so you can look at this. Okay, now remember we look at this first. Just to bring it back to mind, make sure you know our angles, right? Because you can see questions like this. Questions like this can come into play tomorrow. So it's highly possible, right? So deal with your angles and make sure you know your angles. And then we'll apply that to this here, this polygon. Alright? So make sure you know these. Oh, I don't think so. Right, so make sure you know those, right? So let's look at this. Oh, so I'm taking questions from different papers, more recent, from 2021 come up to 2024, doing questions from different papers, right? Different types of questions you can see in the exam tomorrow. So we're looking at here a question where your angles, you have to know your angles, alright? So you can apply to this. So let's apply our knowledge of our angles to this. And also to this question we're going to look at next. Alright? And then we look at some coordinate geometry and functions after that. You have to make sure you know coordinate geometry and functions, alright? You can also look at a linear programming, try to look at that, and probably something on stats. We'll see if we can do some stats. Yeah? Okay, yeah, let's see what we can get done. Alright, so they want us to determine the values of Q and R. Q and R, right? Now, when you look at that diagram, what do you see? You see parallel lines. Good? And remember, when two lines are parallel, keep in mind the angles that comes into play when lines are parallel. Good? Let's get familiar. When lines are parallel, you know you have parallel lines. If I draw a transversal, transversal is a line drawn to cut those two parallel lines. And we looked at this last time when we were doing bearings and circle theorems, right? So it came into play. So you know when you have this Z shape, this angle is equal to that angle. Remember that angle is called what? Alternate angles. Then you have your F shape, where this angle is equal to this angle, and that is known as what? Corresponding angles. Show the angles, because certainly you're going to see angles somewhere. And if you have two lines parallel and you have this box shape, then remember the two interior angles when added must be equal to 180. Both angles, when you add them together, you get 180. So if you know one, you can always find the other. This is called co-interior. Co-interior angles, alright? So let's see, I'm seeing two parallel lines. From the time I look at these are the two parallel lines here with arrows on them, not these. Good? Those are transversal lines which will cut your parallel lines. Now, let's see if any of those can be used to help us to find P. Good? To find Q, sorry. Start with Q, right? To find Q. So, to find Q, well, what is to find Q first? We can do one of two things. If you look, the F shape or corresponding angles can come into play along with straight angles. Remember, straight angles will be where you have a straight line and a straight angle is always equal to 180 degrees. So look at it here. I am seeing my F shape. I have my two parallel lines here. And look at my F shape. This is the stem of my F. Stem of my F. Good? And if this is 54, it means this angle here will be 54 degrees. That angle is 54. And what I can do now is to subtract 54 from 180 because this is a straight line and straight angle to determine what is Q. Yeah? So Q, when they ask us to determine the values of Q1, Q will be equal to 180 subtract 54. They didn't ask to give reasons, right? Sometimes they'll ask you to give reasons, but they didn't ask to give reasons. All they wanted you to do was find the angle. So it's up to you now to see where the angles are applicable. So I'm seeing the F shape, two parallel lines. This is the stem of my F. That's the stem of my F, my two parallel lines, and therefore this angle is equal to that angle because of this corresponding. And therefore, if this is 54 degrees, I can subtract 54 from 180. And what's 180 subtract 54? 126 degrees. So angle Q is 126 degrees. Now let's find angle R. So to find angle R, what can I do to find angle R? Yeah? To find angle R, I can do one of two things. One of two things can be used to find angle R. And you have to pay attention to this angle as well. So when two lines cross, they meet at a point. The two angles that are opposite to each other are equal in size. These two angles are said to be vertically opposite. So that is A, this is A. If this is B, then that is B. So you have vertically opposite angles can come into play. So I'm simplifying now. I can use one of two things. I can use vertically opposite because these two lines cross and these two are said to be vertically opposite. So R is basically 54. Or I can use co-interior. Look at my box shape here. Two parallel lines in the box. You see the box here? That's a box shape. And therefore what I can do is to subtract 126 from 180, which will also give me 54. So making sure we can recognize those angles, right? So when lines are parallel. So I'm going to say here, I'm going to use for R is 54 degrees, and I use vertically opposite. Alright? Vertically opposite. And let me give you the reason. You're going to then answer the reason. Let me state it. But vertically opposite. Angles. And this is 126 for corresponding and straight angles. Corresponding angles and straight angles. Good? So I'm giving you a reason even though they didn't ask for it, right? You just want you to state the size of the angle. But I'm placing the reason there so you can see why or how the angles were obtained. Then they ask us the next part of this question. Give a geometrical reason why. And so this one I wanted to give a reason. Why angle P is 71. This angle P here is 71 because we can use what? Z shape. I can use the Z shape. Yeah? Look at it. These two lines are parallel. This is the transversal. Look at the Z here. Wap, wap, wap. That is Z shape. That's alternate angles. So angle P is alternate to this one, 71 degrees. So you can state here for that part of the question, part 2, P is equal to 71 degrees. And what's the reason for alternate angles? Alright, that's a reason why. Okay? Alternate angles. Because we see the Z shape here. So P is 71. So make sure you know your angles, and especially when lines are parallel, the three important angles. Alternate, corresponding, co-interior. Make sure when two lines cross and meet at a point, we know that this is set to be vertically opposite. So vertically opposite. Okay. Alright, so this is vertically opposite angles. So make sure you know those angles and you know them well. Alright, because you can see questions tomorrow based on those angles. So, for example, let's look at this too. Let's look at this type of question. Alright, this you can see, it's very possible you can see one like this tomorrow. Right, with it's a polygon. A polygon is a figure with many sides. Starting from a triangle, to a quadrilateral, to a five-sided figure, pentagon, hexagon, six-sided, and so on, right? So, and I gave an important formula previously. So I'm going to find the sum of interior angles of any polygon. That formula is what? S is equal to n subtract 2 times 180 degrees. Make sure you know that formula. That will help you to find the sum of all interior angles. All these angles here. Sum of all these interior angles. Alright, so you know what the sum of all those interior angles, what that is equal to, so make sure you know that formula. So, The question says in the diagram below, not drawn the scale, shows a pentagon. A pentagon is a 5-sided figure. 1, 2, 3, 4, 5. Good? In the pentagon, and look at it here, look at what is stated. Y, Z, and XW, right, are parallel. Parallel lines again, huh? Parallel. So if they are parallel, and again you have a transversal, you have certain angles that can come into play to help you. Very important, right? And XY, and you see, XY is parallel. So these two are parallel. You see the arrows moving in the same direction, and these two are parallel, moving in the same direction. Right? Angle XYZ is 140 degrees, and angle VZY is 90 degrees. Good? What I want us to find? Determine the value of angle WXY. So they want us to find the angle of the size of angle WXY. So 1. Determine one angle WXY. Now, first thing we have to recognize what is angle WXY. Remember, always look at the letter in the middle. That's the fixed point of your angle. And the two sides are WX and XY. So WX and XY, X is your fixed point. So this is the angle here. The angle is located at X. You want to find that angle. So to find that angle, again, so the reason for us doing these questions is to see where those three important angles or parallel lines can come into play. If you look, these two lines are parallel. This is a transversal, so you have this angle coming into play. You have the box shape. You have that box shape coming into play. So this is ZY and this is XW. Alright? So this is 114 and you want to find this angle. So what can come into play there? Co-interior angles. Co-interior angles. So what I have to do now to find angle WXY. So angle WXY will be 180 subtract 114. And 180 subtract 114 is what? $66 degrees. So this angle is 66 degrees. Alright? And then they also ask us to find angle ZVW. ZVW. So they want us to find that angle as well. Good? ZVW. 2. So first we need to recognize what is angle ZVW. So ZVW is here. V is your fixed point, good? And it occurs between ZV and WV, good? So how are we going to find that angle? Again, these two lines are what? Parallel as well. And because they are parallel, we can find this angle, because we don't know this angle yet, and that angle is important to find because once we find this angle, then it's easy for us to find this angle here because this is a pentagon. And it's important for us to know the sum of interior angles of a pentagon. Once we know what all the angles add to give, then we can, once we know 1, 2, 3, 4, all we have to do is to subtract that from the sum of interior angles of a pentagon. And what is the sum of interior angles of a pentagon? Let me do it on this side. Sum of interior angles of a pentagon. How many sides we have? 1, 2, 3, 4, 5. So therefore I'm going to replace n with 5. Subtract 2 from by 180. 5 subtract 2 will give me 3. 3 by 180 will give me what? 540. So 540 degrees will be the sum of all the interior angles. So I got this angle which is 66. I can find this angle now. How? Because these two lines are parallel. And I'll have co-interior angles in box shape here. See the box shape here? Two parallel lines transversal of the box shape. So now I can find this angle here. So before we find angle ZVW, let's find angle XWV. Let's find that angle there first. So angle XWV will be what? Because of co-interior angles, it's going to be 180, subtract 66, and 180 subtract 66 will give us 114 degrees. Alright, so this angle is 114 for co-interior angles. Alright, we got 66 as well for co-interior angles. Make sure you know those angles. So this is 114. And therefore, we can easily now find angle ZVW. So angle ZVW will be to add all those angles and subtract from 540. So this will be 540 subtract 98 plus 114 plus 66 plus 114. Yeah? And let's work it out. What are we going to get? 98 plus 114 plus 66 plus 114. 392. So 392 from 540 will give us what? 148. Alright? So that angle there is 140 degrees. So with these questions, again, your angles, this is a polygon. You should know that formula for the sum of interior angles of a polygon. If it's a 6-sided figure, you can use that formula to determine what's the sum of interior angles. So please make sure you know it, alright? Okay, alright, let's look at let's look at some coordinate geometry here. Alright, yeah? It's an important question, coordinate geometry. I'll start off with the 29th. I'll start off with this one first. And then we'll jump to the 2024. After that, we'll do some functions and relations, because that for sure will come in your exam. So make sure you know your functions and relations. Probably I'll do linear programming, and then probably I'll do something with statistics, and then I'll close up because, like I said, I'm not 100%, right? There's some stomach bug going around. So, all right. So let's look at this. All right. Oh, remember, well, I did that last night. Look at the video from session 4, right? You saw where I sketch the quadratic. So look at session 4 and you'll see it. Yeah? So there's a question with that. I have to sketch. Yeah? Alright, no problem. Alright, let's look at coordinate geometry now. Coordinate geometry and functions are two topics that they bring in the exam almost every year. Alright? And you need to ensure you understand your coordinate geometry and of course functions. So with your coordinate geometry, simple things you need to know from gradient of a line, and know your formula. M is equal to y2 subtract y1 over x2 subtract x1. Make sure not to get in the midpoint. The midpoint is what? x1 plus x2 over 2, comma y1 plus y2 over 2. You should know the formula to find the midpoint of a line between 2 points. Also make sure you know how to get the length. And that is the square root of open brackets x2 subtract x1 in brackets squared plus y2 subtract y1 in brackets squared. You should know that formula for your length. And also you should know how to find the equation of a line. So using y is equal to mx plus c. You should know that, alright? Also for coordinate geometry, you must know when lines are parallel. So you should know 1, 2, 3, 4. You should know about when lines are parallel, so parallel lines. So when lines are parallel, they move in the same direction, but their gradients are the same. So these two gradients are always the same. And make sure you know about perpendicular lines. Perpendicular lines. So these are key things when it comes to coordinate geometry. Perpendicular lines are lines that meet at right angles to each other. Yeah? And if you know the gradient of one line, you can always find the gradient of the other. If this is M1, and I have to find M2. M2 is the negative reciprocal of M1. That's very important. So if you know M1 and you need to find M2, right? M2 is the negative reciprocal of M1. Alright? And when you take these two gradients and multiply them, you're supposed to get -1. So when two lines are perpendicular to each other, they meet at right angles. And when you multiply both gradients, so this is M1 by M2, you're supposed to get -1. Keeping in mind M2 is -1 over M1. Negative reciprocal. We'll see via one of these questions where this will come into play. Yeah? So the negative reciprocal for perpendicular lines. Alright? So key things you want to make sure that we know when it comes to coordinate geometry. And also you have to know there's something called a perpendicular bisector. So let me just take note to put that here. The perpendicular bisector. That's when one line meets another at right angles, but must pass through the midpoint. So this is the midpoint. So this line, which is perpendicular to this one, they meet at right angles, but it must pass through the midpoint. This is your perpendicular bisector. Good? It passes through the midpoint. Yeah? And you also have to know for coordinate geometry, when two lines, and you'll see from, I think it's from 2024, when two lines meet at a point, to find that point of intersection, simultaneous equations will come into play. So simultaneous will come into play in your coordinate geometry. This is why you have to know how to solve a pair of equations simultaneously. So you're going to see that also come into play in 2024. Alright? So let's start over 2019 and then we'll jump to 2024. Alright? So this question here, so keeping all this important information here, and let's look at 2019. You have this line drawn. This line drawn crosses the x-axis. It meets the x-axis at P. So this is known as your x-intercept. And it crosses the y-axis. They didn't name it, but it crosses the y-axis at that value. That is known as the y-intercept. Now the coordinates of the x-intercept, and please make sure you know how to recognize the coordinates, because students have problems recognizing the coordinates of a line when it cuts both x and y axes. Right? So when a line cuts the x-axis, you have to know what will be the coordinates of this point P. The coordinates of P will be what? This is 0, 1, 2, 3, 4, 5. So it meets the x-axis at 5. So the coordinates of P, when a line cut or meets the x-axis, always remember the y coordinate of that point will automatically be 0. And x will be 5. So the coordinates of P, you have to say the coordinates, both x and y, is going to be 5, 0. Alright? That's 5, 0. So the y coordinate will always be 0 and x in this case will be 5. You have to know this for linear programming too when you're drawing a line, right? Where it meets the axes. And this here is my y-axis. Or y-intercept, sorry. So to determine where that line cut or meets the y-axis, look at it here. This is 0, 1, 2, 3, 4. So the coordinates of the y-intercept, where the line meets the y-axis, it meets at 4, but the coordinates will be, when a line cuts the y-axis, just keep in mind, is the y-axis, meets the y-axis, so x is automatically 0, and y will be 4. So those are the coordinates. Because students will see a coordinate geometry question, and when the lines meet the axes, they can't correctly state what the coordinates are. Okay? So when it meets the x-axis, y is automatically 0, x is 5. When it cuts the y-axis, the y-intercept, x is automatically 0, y is 4. Good? So let's see what they ask us in this question. Right, they want the gradient of the line. So to find the gradient of that line, I know the line will cut the y-intercept and x-intercept. So I have 2 points. I have the coordinates of 2 points on that line, so I can find the gradient, and I'm going to use that formula to find the gradient. So let me find the gradient. So part 1, gradient of line. Make sure you know your formula to find the gradient. The gradient is denoted by common m, and it's y2 subtract y1 over x2 subtract x1. You should know it. The 2 points we're going to use are 0, 4 and 5, 0. And I always advise you to label the coordinates, so when you substitute into your formula, you will not make mistakes. So I'm going to call this x1, y1, and if that's x1, y1, the other will be x2, y2. So let me substitute into my formula for the gradient. Common m, y2 is 0, subtract y1 is 4. Over x2 is 5, subtract x1 is 0. 0 subtract 4 is negative 4, 5 subtract 0 is 5. So my gradient is negative 4/5, hence the reason why my line slopes that way. When the gradient is negative, your line is a left-hand slope. So the gradient is negative 4/5. So we have our 2 points and we figured out what is the gradient. Alright? So let's look at the next part of this question. What is the equation of that line? What is the equation of the line? Equation. So let's find the equation, part 2. The equation of the line. So we have to find the gradient, part 1, now we're into part 2, which is the equation of the line, right? So let's come back to the diagram here. So we want to find the equation of this line. And to find the equation of a line, what's the formula we're going to use? Y is equal to mx plus c. Please make sure you know how to find your equation and the formula. So the equation of a line, it is y is equal to mx plus c. And in finding the equation of a line, all you need are basically the value of m and c. Those are the only 2 letters in that formula you're going to replace with numbers. Y and x will stay as is. So you need to find a value for m and c. So m is easy. M is your gradient, which we found in part 1, negative 4/5. So I'm going to replace m with negative 4/5. And to find c, I need to replace y, m, and x with numbers so I can find c. Alright, I get c as a value. I need to replace this y with some number, this m with a number which is negative 4/5, and x with a number. So what numbers am I going to replace x and y with? Where are those numbers coming from? I have 2 points on this line. Grab 2 points. So pick anyone, and it's going to help us to find the value of c. So if m is negative 4/5, let me pick one. Let's go with p, 5, 0. When you go with 0 for it doesn't matter. Let me go with 5, 0. This will be x and that will be y for that point. So I'm going to replace y with 0. I'm going to replace m with negative 4/5. I'm going to replace x with 5 in brackets plus c. Finding the equation of a line, right? Only m and c we need to replace with numbers, yeah? And let's look at what c is equal to. 0 is equal to negative 4/5 by 5 will give me 5 with a 5, 1, 5 with a 5, 1, and end up with negative 4 plus c. And then I'm going to add 4 to both sides, or I will take negative 4 and bring it over to the left as positive 4, c is equal to 4. Alright? And once I've found c, I'm not going to stop here and say that's the equation, you know. The equation, you must rewrite it back in the form. So you're going to rewrite it as y is equal to, replacing m with negative 4/5, x, and replacing c with plus 4. That there is the equation of your line between those 2 points. Yeah? So this equation here is y is negative 4/5 x plus 4. And I don't even need to work out what c is equal to, because if you look, c is the y-intercept, it cuts the y-axis at 4. So you could have simply written your equation as y is equal to negative 4/5 x plus 4. You didn't have to work it out, but if you have to work it out, you know how to work it out. But you didn't have to because it cut the y-axis at 4. So one time you can get what's the y-intercept. Alright? So let's look at the other part of this question. Right, now this part is important because students normally get gradient and the length and the equation, all those things. But the equation, they make mistakes, right? but they normally get the other gradient length and midpoint right. But the equation, be careful with your equation, alright? But they often mess up this part of a coordinate geometry question. The equation of the perpendicular line that passes through P. The equation of the perpendicular line that passes through P. They make a mess of that. So what is this perpendicular line that passes through P? What perpendicular means? It means that two lines must meet each other at right angles. So the perpendicular line that passes through P. This is my, let me just draw a perpendicular line. This is my perpendicular line passing through P. We put the coordinates up here. That's my perpendicular line passing through P, meeting this line here at right angles. Right? So that's a perpendicular line passing through P. So it meets this line whose intercepts are shown, that left hand, so the perpendicular line will meet it at right angles. So they want us to find the equation of this line. The equation of that line. So let's find the equation of that perpendicular line. Let me erase it. So we're going to find the equation, or the keyword, find the equation of the perpendicular line. So if it is the equation, what should come to your mind? The first thing that should come to your mind, part 3, equation of perpendicular line passing through P, right? If you want me to find the equation of that perpendicular line passing through P, the first thing I should write in my notebook when I'm finding the equation of that perpendicular line is the formula for the equation. So this line here, I want the equation of that line. To find the equation of a line, you need to replace M and C with numbers, only M and C. So what will I use as my gradient of this line? Alright? Remember, we look at what? Perpendicular lines. These two lines are perpendicular lines. Good? So when two lines are perpendicular, let me put out the two lines here. I know the gradient of this line. The gradient of that line we got previously to be negative 4/5. And just keep in mind, if you know the gradient of one, you can find the gradient of the other by using the negative reciprocal. So the gradient of this line here is a negative reciprocal of the gradient of this line. Alright? And when you multiply both gradients, you're supposed to get -1. That's a rule for perpendicular lines. When you multiply both gradients, you have to get -1. Look how easy we're going to get the gradient of this line. I'm going to put -1, it's a negative reciprocal, over the gradient of -4/5. Good? So that's a negative reciprocal of -4/5. I put -1 over -4/5, which will help me to get the gradient of this line here, that perpendicular line. But let me simplify. What is -1 divided by -4/5? -1 over -4/5 is -1 divided by -4/5, which is -1 multiplied. And when you divide in fractions, leave the first fraction as is, change your division to a multiplication, you invert the second to become -5/4. And negative 1 by negative 5 over 4 is positive 5 over 4. So the gradient of this line here, I'll call this M1. M2 is is positive 5 over 4. That's the gradient of that line. It's positive 5 over 4. It is a negative reciprocal of M1. Okay? And knowing the gradient of your perpendicular line now, which is 5 over 4. Alright? So I know M is equal to 5 over 4. So I know I'm going to replace M with 5 over 4. I also need to find C. Yeah? So I know I'm going to replace M with 5 over 4, which is the gradient. But I also need to find C. And how am I going to find C? I need to replace Y, M, and X with numbers. I already know I'm replacing M with 5 over 4, but what numbers am I going to replace Y and X with? So when I look at my perpendicular line, the only point that perpendicular line passes through will be 5, 0. We can't use 0, 4 because the only point that line passes through is the point P with coordinates 5, 0. Yeah? So look at what I'm going to do. I'm going to replace Y, this is X, that's Y. I'm replacing Y with 0, M with 5 over 4, X with 5 in brackets plus C. This becomes 0, 5 over 4 multiplied by 5 over 1 will give me 25 all over 4 plus C. And therefore, to make C the subject, I'm going to minus 25 over 4 from both sides, or take positive 25 over 4, bring it over to the right, and change the sign to negative 25 over 4 is equal to C. So you have found the C, and having found the value of C, let us now state what is the equation. So you're not going to stop there and say that's the equation. No. You have to now write it back in the form, because students often make that mistake and they leave it there and say, hey, I find the equation. No. Your equation now is what? Y is equal to replacing M with 5 over 4. That's the gradient of this line. What is the equation of this line? You find it. X, and replacing C with negative 25 over 4. Alright? And that's the equation of my line that is perpendicular line that passes through P. Yeah? So that's a perpendicular line that passes through P. So let's make sure we're clear on this. What I'll do, I'll quickly look at 2024. Let's look at 2024, coordinate geometry again, and then we jump into some functions, alright? No, sorry, I think that I did this sketching in day 3. It was day 3. Yeah? Check day 3. Yeah? Now, the diagram below shows the graphs of two functions on the same axis, on the same pair of axes. So I have two functions. This line represents one function. That line represents another function, right? The lines G and H are perpendicular. Remember what the word perpendicular means. It means that they meet at what? Right angles to each other. Perpendicular. And one time something should automatically stand out, right? The negative reciprocal. If you know the gradient of one line, you can find the gradient of the other using the negative. Just put negative 1 over the gradient of the other line, and that's all. And you get the gradient of the line that is perpendicular. Alright? So, you have those two lines, they meet at right angles, they are perpendicular to each other. And they want us to determine the equation that represents a line G. The equation, and keyword should stand out one time. When I read that, equation, so the first thing that should come to my mind is what? Y equal to mx plus c. That's the first thing that should register in my mind. So, I want to find the equation of the line that represents G. What line represents G? This here. Good? So, to find the equation of the line that represents G, good? So, the equation of G first thing that should come to mind, find the equation of line G. So, I know I'm going to write down my formula. Y is equal to mx plus c. Alright? I know I need to find m and c. Those are the only letters I'm going to replace with numbers. M is the gradient of that line G. So do we have the gradient? We don't have the gradient, but we can't find it. Because this line G, we have the coordinates of 2 points on that line G. Alright? And very similar to the one we just did. 2 coordinates. We have the x-intercept, so that's just in -6 and it's in 3. But remember, those 2 points of intersections can be represented as coordinates. You need the coordinates of 2 points. So this point here, the coordinates of that point, when a line cuts the x-axis, known as the x-intercept, the y-coordinate is automatically 0. And the x-coordinate will be -6. So -6, 0 with the coordinates of this point passing through -6. So the coordinates is -6, 0. This line passes through the y-axis and hence known as a y-intercept. So the coordinates of the y-intercept will be what? When a line meets the y-axis, you know the y value, so x is automatically 0. Good? So we have the coordinates of 2 points on the line, and therefore I can use my formula for the gradient to find m. So let me find m. M is equal to formula y2 subtract y1 over x2 subtract. And now, note, remember writing it as y subscript 2. Some students I can write y2 or write y squared. No, it's y subscript 2. So that 2 has to be at the bottom of your y. Right? Bottom of your y. X bottom of your 2. 1 bottom of your 2 bottom of your x. 1 bottom of your x. Good? So I have my 2 points. -6, 0, 0, 3. What I will always advise you to label the coordinates first. This is x1, y1, x2, y2. Let's substitute into our formula. M is equal to y2, which is 3. That's why this is good to label it. Subtract y1, which is 0, over x2, which is what? 0. Subtract x1, which is -6. But remember, when you write -6, those two signs will collide or coincide. And what you do is you separate by using brackets. Don't forget that. So we're going to get what? M is equal to 3 all over a minus bar minus is a plus. 0 plus 6 is 6. And when you simplify 3 over 6, 3 into 3 is 1, 3 into 6 is 2. So the gradient of this line G is a half. But we're not finished. we want the equation. Now no, the equation can be easily found because we don't necessarily have to go work out C, because if you look, well, you know how to work it out if you have to. But if you look, this line cuts the y-axis at 3. So you know the y-intercept one time. So that's how you can figure it out easy from the graph. So if you see the line cutting the y-axis at a particular value or point, you know what is the y-intercept automatically. So there's no need for us to work it out. If you work it out, you're going to get the same value. Alright, and just to show you, you have to work it out so you'll know if it doesn't cut the y-axis and how you work it out to find C. Right, let's show you. So this will be, so to find C, if we have to work it out, we're going to use y is equal to mx plus c. To find C, I need to replace y, m, and x with numbers. I know I'm going to replace m with a half, and I need to replace y and x with numbers. Where are those numbers coming from? I have 2 points on the line, so pick any one. It doesn't matter which one you pick, you get the same answer. So let me go with 0, 3. So this is x, this is y. So I'm going to replace y with 3, m with a half, x with 0 in brackets. Make sure you put it in brackets. It's not a half 0, it's a half times 0 plus z, plus c. So 3 is equal to 0 plus c, 3 is equal to c. And you see, it cuts the y-axis at 3. But to state your equation, remember you have to write it back in the form. It's going to be y is equal to a half x plus 3. That's the equation of that line, G. Okay? And then they said what? They said the equation that represents the line H. See, it's similar to the 2019 that I just did. The line that equation of the line H. Right? If you look, H is what? H is perpendicular to the line G. Yeah? H is perpendicular to the line G. And if you have to find the equation, if you look, find the equation that represents H, if you have to find the equation of the line H, equation of line H, so I'm going to write here, let me write the equation of G and I'll erase so I can find the equation of H. So this is the equation of G. Y is equal to a half x plus 3. So I wrote the equation of G on its line. Let's find now the equation of H. Alright? So make sure you understand it according in geometry. Love to bring it. So to find the equation of H, first thing that should come to my mind, keywords, find the equation. So what should come to your mind automatically? Y is equal to mx plus c. So that's the first thing I write, right? And you know in that formula, you need to replace m and c with numbers, good? At the end of it all, m and c will be replaced with numbers, y and x stays as is. So, what is the gradient of this line? What's the gradient of H? These two lines are perpendicular to each other. The gradient of this line G, this is H. G, the gradient of the line G, we got that to be a half. Not so? So it's easy now to find the gradient of H. It is the negative reciprocal of the gradient of the line G. Alright? So, this here, I'll call this M1. M2 is the negative reciprocal of a half. Let's put negative 1 over half. And what is negative 1 over half? We'll leave it like that and write it as what? Negative 1 divided by a half. Or negative 1 multiplied by, and when you divide in, leave the first fraction as is, change the division to a multiplication, invert the second to become 2 over 1, which is 2. So negative 1 by 2 is negative 2. So the gradient M2 is really negative 2. Good? So that's the gradient of H. And having found the gradient of H, now I need to find C. And in this case, I have to work it out because the line doesn't cut the y-axis. So you have to go work it out. Yeah, that's why I have to know to work out finding the value of C. So you know that what? M is -2. But how am I going to find C? You need to replace y, m, and x with numbers. Where are the numbers coming from for y and x? I look at my line H. The only point H passes through this point here, whose coordinates will be, it cuts 4, but you want coordinates. So this is the x-intercept, it cuts the x-axis. So you know that automatically, when it cuts the x-axis, you know it cuts at 4, so you know x will be 4, but y is automatically 0. So that will be the coordinates of the x-intercept there for H. So the only point on that line, the only point H passes through that is clear and visible to you will be 4, 0. So this is x, that's y. So I'm replacing y with 0, m with -2, x with 4 in brackets, plus c. So we're going to get 0 is equal to -2 by 4 is -8 plus c, and then I can make c the subject by adding a to both sides. So take -8, bring it to as +8, and you have c. So the equation of the line H, you're not leaving it like that, the equation of H will be y is equal to -2x plus 8. Alright? That's the equation of the line through H. Alright? And let's look at the last part of this question now. Right, we want the coordinates of P. Show all working. Remember when I do the list of things on the board? The coordinates of P. Where is P? So this is P here. We just got the equation of this line to be what? Y is equal to -2x plus 8. Good? So if you have to find the coordinates of P, alright? We have two lines. We have the equation of both lines. We have the equation of both lines. Yeah? So all you're going to do to find P is to solve the pair of equations simultaneously. Some simultaneous equations will come into play here. So for coordinate geometry, once you know the equations of two lines and they meet at a common point, to find the coordinates of that point, you have to solve the pair of equations simultaneously. Okay? So let's go solve simultaneously the pair of equations. So we have, for this part of the question, we're going to find the coordinates of P, right? So coordinates of P. So coordinates of P. So we're going to solve simultaneously the two equations I have on each line. We have y is equal to half x plus 3. And y is equal to -2x plus 8. Okay? So you want to solve them simultaneously. So to solve simultaneously, now when students see fractions, you can use the method of elimination here, and or you can use the method of substitution. It doesn't matter, right? But you know, students, I know you all like elimination, so the first thing I will advise you do, if you have an equation where fractions are involved, because you know when fractions are involved, you make all sorts of mistakes. Good? So, to To avoid using the fraction, remove the fraction from the first equation. We write the first equation where you have no fractions. So you have two equations with no fractions, and then you will solve them using the method of elimination. So how are you going to remove the fraction from that equation? If you have y is equal to half x plus 3, good? And you want to remove that from the fraction, what do? How many fractions we have in this equation? 3. Y over 1 is a fraction, or y is a fraction, is y over 1. You have a half x, which is another fraction, and 3 is also a fraction. 3 is 3 over 1. Yeah? So, what's the LCM of all the numbers in the denominator? LCM of 1, 2, and 1 is 2. So, all you're going to do to remove the equation from its fraction, you're going to simply multiply each fraction by the LCM, which is 2. So you're multiplying 2 by y, 2 by a half x, 2 by 3. This is how you remove an equation from its fraction. So identify how many fractions you have in the equation. Y over 1, a half x is another fraction, 3 over 1 is another fraction. You find the LCM of all those numbers in the denominator. The LCM of 1, 2, and 1 is 2. And what you have to do now is multiply each fraction by the LCM 2. So 2 by y will give you 2y. 2 by a half x. 2 by a half is 1, right? So 2 by a half x will be 1x or x. And 2 by 3 is 6. So it will be easier to work with this equation where you have no fractions as opposed to the equation with fractions. You often make mistakes when you have fractions. Yeah? So, or you can work with it like this too, right? You can work with it like this too, it's up to you. So, we will have, we have converted this equation into one where we have no fractions. Good? And when I'm solving simultaneously, you're accustomed when solving a pair of equations simultaneously. You're accustomed putting your knowns, all your knowns on one side, and you'll see all the constants or numbers on another. So if you want it to look like that, no problem. This will be 2y, positive x comes across as negative x is equal to 6. And this will be y, negative 2x comes across as positive 2x is equal to 8. You're accustomed working with a simultaneous looking like that. Okay? So let's go use the method of elimination now to find x and y, which will represent the coordinates of P. So I label 1, 2. I'm going to eliminate y first, so I have to make sure the numbers in front of y are the same. So I want both to be 2. So I multiply equation 1 by 1 and equation 2 by 2. So multiplying equation 1 by 1, I'm going to get 2y minus x is equal to 6, and I'll call that equation 3. And multiplying equation 2 by 2, I'm going to get y by 2 is 2y. Plus 2x by 2 is plus 4x. 8 by 2 is 16. And I call that equation 4. So now that my two terms involving y are the same, I'm going to subtract. I like to put the subtraction sign in between them. 2y subtract 2y is 0. Just as you see here vertically, you're going to write it down horizontally. Negative x subtract plus 4x is 4x. Is equal to what? 6 subtract 16. Negative x subtract 4x is negative 5x. 6 subtract 16 is negative 10. And then I'm going to divide both sides by negative 5. X is equal to 2. And after I found x, I need to find y. So I'm going to substitute x equal to 2 into any one of the original equations. You pick one or pick two, doesn't matter. Right? You want to put them into any of those as well too, because remember these are the same as those, right? So substitute x equal to 2 into equation 1 or equation 2. I'll put it into equation 2. You have y plus 2x is equal to 8. And let me replace x with 2. Y plus 2 in brackets, y plus 2 times 2 in brackets is equal to 8. Y plus 4 is equal to 8. I subtract 4 from both sides. Y is equal to 8, subtract 4. Y is 4. So therefore the coordinates of the point P will be x is 2, y is 4. So that will be the coordinates of this point P. So x will be 2 here, and y will be 4. As the coordinates of your point P. Alright? So to find, so pay attention and listen to bring, well, I brought it in January, and sometimes I bring some similarities in June, right? So make sure you know your coordinate geometry, and when two lines cross and meet at a point, and if you have a pair of equations to find that point of intersection, solve them simultaneously. Alright, let's look at some functions. Alright, let's look at this one here. Alright, now we have here the functions f and g are defined by. Now when I give you treated with functions and relations, you have to know three very important components of the functions and relations. One is you have the whole concept of substitution. You have two, the composite function. You take them and you bring them together, you combine them. And you have third, the inverse of a function. So you have substitution, you have the composite, and then you have the inverse. This you're going to see for sure in your exam tomorrow. With your eyes closed, you enter the exam, you open up paper, open it, you see functions. Functions is always there. Alright? Always there. So, the functions f and g are defined by those two. So you have these two functions. So let's make sure we see something like this, we know how to treat with this. State a value of x that cannot be in the domain of f. Sometimes they'll bring questions like this, right? What value of x that cannot be in the domain of x? Meaning, what value of x does not satisfy that function f of x. And it's a domain of f, and we are focusing on this f of x here. Now, f of x becomes undefined. Undefined means it can't work out, it doesn't exist. When if I have 9 over 2x plus 1, this is defined when I replace a value of x, that will help me to get a result for it. So if I replace x with 1, 2 by 1 is 2, plus 1 I get 9 all over 3, and I can work that out. If x is 2, 2 by 2 is 4, 4 plus 1 is 5, 9 over 5, we get a result. If I have my denominator as 0, anytime the denominator is 0, then this is said to be undefined. It doesn't exist, it cannot work out. Anytime the denominator is 0, it is undefined. It can't work out, it does not exist. So we want to determine what value of x will make this denominator 0 and hence make f of x undefined or does not exist. So when I ask you to state a value of x that cannot be in the domain of f, alright? So that value of x that will make that function undefined. Okay? And therefore it cannot be in the domain. You can't use it because it's going to make that function undefined. That occurs when the denominator is 0. So what value of x will make that denominator 0? So you have here, this is part 1. F of x is equal to 9 all over 2x plus 1. What value of x will make that denominator 0? And if you're not sure, this is what you do. You simply say take the denominator 2x plus 1, put it equal to 0. So you take that 2x plus 1 in the denominator, put it equal to 0, and you can solve for x. Plus 1 comes across as negative 1, and then I'll divide both sides by 2. X is negative a half. So negative a half will be that value of x that will make that function undefined. If you replace x with negative a half, what you'll get? This will be 9. 2 times negative a half plus 1. 2 by negative a half is negative 1. Negative 1 plus 1 is what? 0. So the value of x that cannot be defined in the domain of f is negative a half because that will make the function undefined. And if you're not sure how to find it, just take the denominator, the expression in the denominator, the 2x plus 1, put it equal to 0 and solve x. That's it. X is a half, negative a half. Alright? Let's look at the other part of this question. Right. Find in its simplest form an expression for fg of x. Fg of x will be the composite function. So we take in the two functions f and g we had, or that was given, or that is given, and we want to find an expression representing the combination of the two. So you have here f of x, which is 9 over 2x plus 1, and g of x, which is equal to x minus 3. Good? And what we want to do is find in its simplest form an expression for fg of x. So we're going to find an expression for fg of x. We're going to combine those two together to get an expression representing the combination. Take them and bring them together. How are we going to bring them together? This is what you do. You leave, alright, so you have the expression on your right, which is g of x. You have the expression on your left, which is f. So I'm going to leave my expression f on the left as is. I'm going to replace this g of x I have boxed off here with x minus 3. Good? So what does f of x minus 3 mean? It's simply this. If I have f of 2 simply means if you have a number instead of an expression, but the same concept applies. If you have f of 2, it means you're going to replace this x inside here with 2. So this would have been 9 all over 2 times 2 plus 1. 9 all over 4 plus 1, which is 5. Yeah? That is if you have f of 2. But I don't have f of 2, I have f of x minus 3. So it means I'm going to replace this x here with the x minus 3. Because remember, they wanted to obtain an expression in terms of x, not a value, an expression. So the answer must involve x. So this is what you're going to get. You're going to get here now, this will be equal to 9 all over 2, and I'm replacing this x with x minus 3. So you put x minus 3 in brackets, plus 1. And if you want to simplify that further, 9 all over 2 by x is 2x, 2 by negative 3 is negative 6 plus 1. And if you want to simplify that further, it becomes 9 all over 2x minus 5. That is the expression in terms of x. It's fg of x, so it's an expression in terms of x, representing the combination of the two, called a composite function. So you leave f on the left as is, that's all, just leave this f on the left as is. Replace the g of x with the expression x minus 3, put that x minus 3 bracket. And what does f of x minus 3 mean? It means it is taking this x minus 3 inside here and replacing the x in this expression for f of x. You're replacing this x with that x minus 3. So you get 9 all over 2, in brackets x minus 3 plus 1. You remove your brackets and break it down, that's what you get. That's the expression representing fg of x. Good? Let's look at the next. Right. F inverse of x now. F inverse of x. So we're looking at the next part here. F inverse, the inverse of a function. So I'm erasing here. So f inverse of x, so this is part B. F to the power of negative 1x. When you see f to the power of negative 1x, it means the inverse. F to the power of negative 1. And just remember, to find the inverse of a function, you have to implement 3 steps. Don't forget that. You're going to see it tomorrow. You're going to see it tomorrow. You have to implement 3 steps. The first step is, if you're finding the inverse of f, not g, the inverse of this function you need to find, right? So, there are 3 steps. Now, f of x and g of x, they both mean y. You can replace both of them with y. Alright? They're the same as a y. So, you're going to, instead of writing f of x, you're going to start by saying let y. So, you're replacing the f of x with y. Let y be equal to 9 all over 2x plus 1. That's step 1. Good? Step 2, you interchange x and y. So that's step 2. So step 1 is to let y be equal to step 1. Let y be equal to the function. Step 2, you interchange x and y, meaning where I see y, I put x, and where I see x, I put y. So you interchange x and y, let's interchange them. But this is the part where students have problems, because again, they do this better. You let y be equal to the function, they interchange x and y, yeah, you do that very good. But then the last part is where they have challenges, where you have to make y the subject of the formula. This is where changing the subject of the formula, or making the subject of the formula, or transposition comes into play. Changing the subject of the formula. Alright? Or transposition, when this comes into play. If you have x, 9 all over 2y plus 1. Alright? We're testing the knowledge of equations here. Alright? You want to make y the subject. You want to get y by itself. Okay, that's making y the subject means you want y alone. How are you going to get y by itself? Now, 9 all over 2y plus 1 is a fraction. Okay? X can also be expressed as a fraction. X is the same as x over 1. 9 all over 2y plus 1. I have one fraction on the left, I have one fraction on the right. 9 all over 2y plus 1 is one fraction, right? And when you have one fraction on the left, one fraction on the right, to remove it from its fractional form, you can simply cross multiply. Yeah? So I'm going to multiply x by 2y plus 1. And when I'm showing that, I have to write x and 2y plus 1 in brackets. So we just write x 2y plus 1 and don't write this. You have to put 2y plus 1 in brackets. Good? And that shows x multiplied by 2y plus 1. And I'm going to multiply 1 by 9, which is what? 9. So what I've done now is to remove any fractions. So I have no fractions. Okay? And what I want to do is to make y the subject now. So I'm making y the subject. So this is a fraction on the right. X is also a fraction. It's x over 1. 1 on the left and 1 on the right. Cross multiply, remove it from the fraction. Good? But how am I going to make y the subject? Now you can do one of two things. You can remove brackets. When you see brackets, you can remove the brackets. Or remove brackets. X by 2y will give me 2xy or 2yx, if you want to write it like that. X multiplied by plus 1 is plus x is equal to 9. My aim is to get this y by itself, right? To make y the subject. So what am I going to do to make y the subject? I need to first remove this plus x. So I'm going to remove that plus x by subtracting x from both sides. I take positive x and I bring it over to the right as negative x. Or if you choose to do it, no problem. So this is going to be 2x. Y is equal to 9 subtract x. And then I can make y the subject by removing the 2x in front of my y. Yeah? And this is 2x multiplied by y. So if I need to make y the subject, I need to remove 2x. And the opposite of multiplication is what? Division. So I'm going to divide 2xy by 2x. And what I do to one side, I must do to the other. I'm going to divide 9 minus x by 2x also. And what is going to happen? My 2x is on the left of the equal sign will divide into each other to give me 1. And I'm going to have y by itself, which is equal to 9 minus x all over 2x. And this here, and it's always going to write as your last line, don't leave it like that. Write as your last line, f inverse of x is 9 minus x over 2x. What I've done here is to implement how many steps? 3 steps. This is step 1. You let y be equal to the expression. Step 2, you interchange x and y. Where you see y, put x. Where you see x, you put y. But step 3 is a step where students often make mistakes. You have to make y the subject of the formula. One fraction on the right, one fraction on the left. Cross multiply. No more fractions. Then you work towards making y the subject. You remove the brackets. Remove this plus x. Minus it from both sides. And then you remove the 2x in front of y, and you've made y the subject, which represents f inverse of x. So make sure you know those 3 steps. Alright? Okay, let's look at let me do 2024. 2024. And after that I will do I think I may do a linear program representing, right? So I did a linear programming question. Yeah, do a linear programming. And if I have time, so I could probably just do a stats or statistics, right? Yeah, then we'll call it a night. My stomach is starting to act up a bit. All right, so let's look at this one, the 24 here. They gave us two functions. One is f of x, which is 2 minus 5x, and the other is h of x, which is 5 to the power of x. They want us to A, calculate the value of f of 4. How are we going to find f of 4? Again, simple substitution. So where I see x in that expression, I'm going to replace it with what? 4. That's all. So just replacing this x with 4. So this is simply 2, 5, and of course 2 minus 5 and 4 in brackets. Good? And of course I can simplify that to get a value as my answer. 2 negative 5 by 4 is negative 20. I get negative 18. Please don't say 2 minus 5 is negative 3 then by 4 to give you negative 12. You have to multiply negative 5 by 4 first, and you say 2 minus 20 will give you negative 18. Alright? That's 1. Let's look at 2. H of 0. H of 0 is the same substitution. So I'm focusing on my function h of x, 5 to the power of x. And I'm going to replace the x in that expression with 0. This is where you have to understand and know your laws of indices. 5 to the power of 0. Any base raised to a power of 0, the answer is always 1. That's it for that one there. Alright? Then we have part 3. f(h) of negative 2. That's a composite function combining, and you want an expression for f, so you want a value, sorry, for f(h) of negative 2. You want a value. When you see a number in brackets, it means that they want you to obtain a value. If you saw x in it in the brackets, then you know the answer will be an expression in terms of x. Alright? So how are we going to get a value for that? I need to find h of 2 negative 2 first. So I'm going to find h of negative 2 first. What is on the right? Let me work that out first. So let me get a value for h of negative 2. H of negative 2 means I'm focusing on my expression for h of x, 5 to the power of x. And where I see x, I'm going to replace it with negative 2. This is 5 to the power of negative 2. Alright? And 5 to the power of negative 2, you can work it out as a decimal, put it into your calculator, get a result. But 5 to the power of negative 2, if you want to move this, and this is where your laws of indices will come into play. If you want to move this from a negative power or index to a positive power index, 5 to the power of negative 2 is the same as anytime you move it from a negative power to a positive power, you write 1 all over 5 and negative 2 becomes positive 2. And 1 all over 5 squared is the same as 1 all over 25. So that's h to the power of negative 2. But remember, you want to find fh to the power of negative 2. So really, f h to the power of negative 2 is the same as, and replacing this h to the power of negative 2 with 1 over 25. You're really finding f of 1 all over 25. That's what they're really finding, f of 1 all over 25. Because you just got h of negative 2 to be 1 over 25. You can express it as a decimal too if you want. When you find 5 to the power of negative 2 using your calculator. On your calculator, 5 to the power of negative 2 is what? .04. Alright? Yeah? 0.04 if you wanted to express it as a decimal. So this would have been f of 0.04. Right? And I'll leave it as 1 over 25. So f of 1 over 25 is what? It means I am going to substitute this 1 over 25 for my x in the expression f of x. F of 1 over 25 or f of 0.04. Let's replace the x with a 1 over 25 or 0.04. And therefore you're going to get a result of f(h) of negative 2. So we'll count h of negative 2 first. And now let's find f(h) of negative 2, which becomes f, leave f, replace h of negative 2 with 1 over 25 for 0.04. And this becomes 2, subtract 5, and in brackets 1 over 25, which becomes 2, negative 5 by 1 over 25 is negative 1/5, and 2 subtract 1/5 is the same as LCM 5, 1 into 5 is 5, 5 by 2 is 10, 5 into 5 is 1, 1 by 1 is 1, 9 over 5 or 1 4, or 1.8 if you want to write it as a decimal. So f(h) of negative 2, you should know how to treat with this because they love to bring questions like that with your functions. Work out h of negative 2 first, find f(h) of negative 2 now. So which will be f of, and h of negative 2 is 1 over 25, so you're really finding f of 1 over 25. So you take the 1 over 25 and you replace the x in the f of x, and you work it out to get 1 4/5. So make sure you know how to treat with such, right? Find f inverse of x. You want us to find the inverse? Again, find the inverse. So let me erase here. So you want to find the inverse of x, part B. F inverse of x. So how do we find the inverse? Again, how many steps? 3 steps. Don't forget, 3 steps. So the first step, you replace the f of x with y. Then y will equal to 2 minus 5x. Step 1. Step 2. Interchange x and y. So when you see y, you're going to replace it with x, and when you see x, you're going to replace it with y. And this is the part where students have problems. Make y the subject. Of the formula. How do we make y the subject of the formula? You want to get this y by itself. So you want to remove this 2 and add negative 5. Yeah? Some students may take the negative 5y, put it on this side, put positive x on that side, no problem. If you want to make negative 5y, positive 5y, no problem. Or if not, just working as is, you remove the 2 first, So remove 2 by subtracting 2 from both sides. So positive 2 comes across as negative 2 is equal to negative 5y. Don't forget, negative 5y when we remove that 2. And therefore, to make y the subject, you want to remove the negative 5 in front of the y. So you're going to remove that negative 5 in front of y by dividing both sides by negative 5. And therefore, y is equal to x minus 2 over negative 5. So you can leave it like that if you wish. And you write at the end, f inverse of x minus 2 over negative 5. And that is the expression for the inverse. Remember, 3 steps. Alright? And given that f of x is equal to a plus bx, determine the values of a and b. F of x. Right? That is equal to a plus bx. Find a and b. So, we need to find f of x first. And then, we identify from that what is a and what is b. When we find f of x, hopefully we should get it in that form, which will allow us to clearly recognize what is a and what is b. So let's find f of x first. So f of x. That is a composite that's combining the two f functions together. That's combining them. Alright? Sometimes you see f squared x is the same as the same f of x, huh? Remember that. If you see f squared, it's f of x, good? Yeah? So, how are we going to treat with that? We are going to, and it's an expression you're going to get, you're going to take what is on the, alright, I'll box it off, good? I will leave my f on the left as is. I'm going to replace the f of x I've boxed off with 2 minus 5x in brackets. And what is f of 2 minus 5x? Simply, where I have my x and my f of x, I'm going to replace it with that 2 minus 5x. So this becomes 2 minus 5, and I'm replacing that x with the 2 minus 5x I have in brackets there. Yeah? And now I want to simplify where I can get in the form a plus bx. You're not going to say 2 minus 5 is negative 3, then remove brackets. Please don't. You leave your 2 as is. You multiply negative 5 by 2, which is negative 10. And you multiply negative 5 by negative 5x, which is plus 25x. And that will simplify to become 2 minus 10 is negative 8 plus 25x, which is now in the form a plus bx, yeah? So we can identify what is a and what is b. So a in this case, therefore a is negative 8 and b will be 25. So we have found a and b. So f of x. Leave f on the left as is, replace the f of x and have in the box there with your expression 2 minus 5x. So what is f of 2 minus 5x? Just simply replace the x in the expression with the 2 minus 5x you have in the brackets there. And then you simplify and then get your values for a and b. Alright? So your functions and relations. What I'll do is probably do like Alright, so let's do a linear programming. I do like about probably 2 linear programming questions. So I'll do one where they actually gave you they wanted to state one of the inequalities and to determine what's the maximum or minimum value. Alright? So we do one where they give you the all inequalities, the satisfied region, they give you that. So you do one like this, and you do one where we have to actually draw the graph. Alright? Right, so what is linear programming? Linear programming deals with inequalities. These inequalities are derived from conditions. So we give us some conditions, or some we call them constraints, and use those conditions or constraints to help us to create inequalities. So you have conditions, you can put them into inequalities. Alright? These inequalities are then represented on a graph. On your graph, you're going to have what you call the satisfied region. This region I have shaded here is my satisfied region. Then I'm going to use the vertices of the satisfied region. So this here, so if you're going to see a triangle, right? So that satisfied region, we have a triangle there. So I'm using the vertices of my satisfied region. Alright? To help me to determine what is asked, which is to find sometimes the maximum or minimum value. So you're using it, so then you'll use vertices of satisfied region, vertices of satisfied region, along with an expression to find the maximum or minimum value. So that's what linear programming is about. You given conditions, you can put them into inequalities, and then you have now inequalities are represented on a graph. You look at the satisfied region, then you use the vertices of the satisfied region, which is that shaded region here, tell you along with an expression, and we're going to see this is the expression they gave here, tell us to determine what's the maximum or minimum value. Good? Now, what is important with linear programming is understanding how inequalities are represented on a graph. Remember, an inequality will involve inequality symbols. So an inequality will have inequality symbols less than or equal to, greater than or equal to. The change is marked. Alright? So inequality will have an inequality symbol. Less than or equal to, greater than or equal to. Now, inequalities can be represented on a graph. Good? Now, when you're representing inequalities on a graph, what you need first are reference lines. Inequalities are represented by shading from the line. So the inequality will be represented by shading from the line. Okay? So it's like what is that's a shading. It's shading from the reference line. So you see the solid line here, those solid lines, those are reference lines which are represented by equations. So the equation of the line, and then the inequality is represented by shading from the line. So for example, if I have a reference line that is, if I can do it here. If I have a reference line that is vertical, good? And normally a vertical line is, for example, if you have x equal to a. Alright? And when we did transformations, you have a line, for example, x equal to 7 will be a vertical line passing through 7 on the x-axis. So if you have x equal to a, that's a vertical line. So anything to the left of that vertical line, when I shade this way, that represents less than. Or I could say less than or equal to. If I shade it to the right of that line, that represents what? Greater than or equal to. Good? If I have a line, I can have a line sloping this way. Well, an equation of a line this way, horizontal slope. Good? And a horizontal slope would be, for example, if I have y is equal to b. Now when we did transformations, we have a line horizontal, that's like a mirror line, y equal to say 7, a horizontal line passing through 7 on the y-axis, right? Yeah? That's a line y equal to b. That's the equation of the line. But the inequality is represented by shading from the line. So if you shade above the line, that is what? Greater than or equal to. If you shade below the line, that is a less than or equal to. Good? You can have lines that are sloping. So a line that is sloping this way, a right-hand slope, or a left-hand slope. If it's a right-hand slope or left-hand slope, both equations are the form y equal to mx plus c. Both will be of that form. Alright? And a right-hand slope, the gradient is positive. So you have a right-hand slope. Or you can have y is equal to negative mx plus c. So you have a left-hand slope, and that occurs when the gradient is negative. But both have that form, general form, y equal to mx plus c. So if you shade above that line of a right-hand slope, this is greater than or equal to. If I shade below that line, this is less than or equal to. Alright? And if I have a left-hand slope, if I shade above the line, this is greater than or equal to. And if I shade below the line, this is less than or equal to. Okay? So you have, with inequalities, you have, linear programming, you have inequalities. And inequalities, we have to know when we represent them on a graph, where do we shade when given our reference line to represent the inequality. So in this case, let's look at this here. So The diagram below shows a graph of 3 lines. So they give you 3 lines. And a shaded region defined by 3 inequalities associated with these lines. So, and I give an example. So the inequality associated with the line 3y equal to x, that's a line. The inequality is 3y greater than or equal to x. Good? So that's the inequality. So the inequality, you replace the equal sign with an inequality symbol. And let's see how that is shown on the line. You have the line here, 3y is equal to x. Good? And the line 3y equal to x. But the inequality 3y greater than or equal to x will be where? Shading above the line. So as you shading above the line, you put it in black. So this is the line 3y equal to x. The line is an equation, but the inequality you shade from the line. In this case, we shade above the line. You saw it falls within the satisfied region. Yeah? But then they ask us to state the other 2 inequalities which define the shaded region. You want 2 other inequalities? Right? So what 2 other inequalities? So you have here part 1. You have this line, look at this line here. This line is x equal to 6. So this line here is x equal to 6, which is a vertical line passing through 6 on the x-axis. That line there is x equal to 6. And on what side of that line am I shading? I'm shading to the right of that line. Alright? And I'll shade to the right because remember all inequalities will be satisfied in a particular region, which is that region we have here. So this region, all inequalities will fall within that region. That region is a satisfied region. All inequalities are satisfied in that region. And for the inequality for x equal to 6 to fall within that region, I have to shade to the right of the line. Alright, so this is me shading to the right of that line. So what is the inequality represented by me shading to the right of the line x equal to 6? That inequality is simply x is greater than or equal to 6. That's all. X is greater than or equal to 6. And it will be greater than or equal to because the line is solid. Something you have to remember, because a dotted or broken line is going to be either less than or greater than. Yeah? If it is solid, it is greater than or equal to or less than or equal to. Good? Let's look at this other, because I want us to state the other 2 inequalities. So the other 2 inequalities will be what? You have the line, you see sloping line now. So you do it up before y equal to mx plus c. It doesn't look like x equal to 6. This is also a sloping line too, or before y equal to mx plus c. So let's look at x plus y is equal to 40. That is the line, the reference line. But the inequality is recognized by shading from the reference line. And where am I going to shade? I'm going to shade below the reference line. So my inequality can lie within the satisfied region. Yeah, I want to determine what's the inequality for that reference line. And in order for my inequality to fall within that satisfied region, I have to shade below the line. I can't shade above it. I must shade below. Yeah? So this is what I'm looking at here. And that's a line whose equation is x plus y is equal to 40. Alright? So what will be the inequality? If I have a line slope in this way and I'm shading below, good? Then I'm going to replace that equal sign with, this will be x plus y is less than or equal to 40. And those are the two inequalities. State the other two inequalities which define the shaded region. Okay? And to show you how those inequalities, if you were to take any point that lies within this region, any point that lies within this region will satisfy all three inequalities. So you have three inequalities, right? You have 3y is greater than or equal to x. Just to show you, if you take any point that falls within that shaded region. Let's take, for example, I'm seeing 10, 10. 10, 10 falls within that shaded region. So let's see if that will satisfy all three inequalities. So any point in that region must satisfy all three inequalities. So let's see if we take a point 10, 10, for example, which falls in the region, 10 on the x, 10 on the y, falls within the region. If I were to put, let's see if it satisfies this first. 10, 10, right? When x is 10, is 10 greater than 6? Yes. So it satisfies this inequality. When y is 10 and x is 10, when y is 10, I'm going to get 3 times 10 is greater than or equal to 10. 3 by 10 is 30. 30 is greater than or equal to 10. So it satisfies that inequality. When x is 10 and y is 10, this is what? 10 plus 10, which is 20. 20 is less than or equal to 40. It satisfies the inequality. So the point 10, 10 will satisfy all three inequalities. But sometimes I might ask, identify a point that will satisfy all inequalities. So look for a point within the shaded region. And that point must satisfy all inequalities. Yeah? If you take a point, if you take something outside of that point, for example, let's take a test point outside of the region. Let's take, for example, this will be 35. 35, for example. This point here, 35. That falls outside of the satisfying region. 10, 10 falls within, right? 10, 10 is there. 35 falls outside of the satisfying region. Right? And let's prove that that is the case. Let's see if let's see if that's the case. So this is what? Okay. Let's take 35. Let's see if it will satisfy all. When x is 30, so you have 35. When x is 30, 30 is greater than or equal to 6. Alright, it satisfies this one. Let's see if it satisfies all. When y is 5 and x is 30, 3 times 5 is greater than or equal to 30. 15. Is 15 greater than or equal to 30? No. So it doesn't satisfy that inequality. Let's try x plus y is less than or equal to 40. 30 plus 5, yes, this is less than or equal to 40, but it doesn't satisfy all three. It must satisfy all three inequalities. Alright? So any point in that region must satisfy all three. So when I talk about a point satisfying, when you take that point and substitute it into all three inequalities, it must make sense, it must satisfy it. Alright? So the two inequalities will be x is greater than or equal to 6 and x plus y is less than or equal to 40. Right? Those are your two other inequalities on that graph. And then it says now the function p equal to 4x plus 3y satisfies the solution set represented by the closed triangular region. Right? So this expression here satisfies that region. Right? Using that expression to satisfy that region. Identify the three pairs of xy values for which p has a maximum or minimum value. So identify the three pairs of xy values for which P has a maximum or minimum value. So you know what those three values are? Those three values are the vertices of your satisfied region. So you're looking at the vertices of your satisfied region. So anytime you have a satisfied region, it is normally in some shape, a triangle, it could be a quadrilateral. So you're looking for the vertices of the satisfied region to help you to determine if a maximum or minimum value can be obtained. Now I'll show you how we determine if it's maximum, how we get a maximum or minimum value. So you need those satisfied points. You need those points, which of course comes from the satisfied region, and preferably you're using points on the which are represented as the vertices of your satisfied region. This is a triangle here, so using the vertices of that triangle. So this point here, this point here, and this point here. All right? Yeah, so this is 6 here. So what are the vertices of those points? So I'm not sure if you've seen it clear on the board, but the vertices will be what? So we're looking at part 2. So the vertices are, let me call this A, let me call this B, and let me call this C. So the vertices of A will be, that will be 6 on the X, and this will be 2 on the Y. So 6 on the X, 2 on the Y. Yeah, 6, 2. Right? So 6 on the X, 2 on the Y. The vertices of B, this is B up here, that looks like 6 on the X, and it falls here. That looks like about 34 on the Y. So 6 on the X, this is B, 6 on the X, 34 on the Y, that's B. And C will be 30 on the X, and 10 on your Y. So C 30 on the X, 10 on the Y. So what they ask for you to identify 3 pairs of XY values for which P has a maximum or minimum value. Those XY values will be obtained from the vertices of the satisfied region. And the satisfied region is a triangle of the outer boundaries. Of course, in the shape of a triangle, so using the vertices of that region. Alright? And then they ask, which pair of XY values makes P a maximum? Which of these values here will make P a maximum? Which? Yeah? So you were given an expression for P. This is part 3. You're given an expression for P. That expression for P is 4x plus 3y. So which of these points here will make P maximum? And what we have to do is to test all to see which one will give us a maximum value. So remember, each one is x. This is x, and that's y. X, y, x, y. So which one of those will give us a maximum value? Alright? And let's see. So linear programming, yeah, so you can bring a question like this, bring the diagram, tell you find inequalities to give an expression to identify the maximum or minimum values. You know, you get your vertices of the satisfied region, and then use your use trial and error. Well, use your test points, which are A, B, and C, substitute into this expression to determine which one is maximum. So let's determine which is maximum. So part 3. When you have the point A 6, 2, x will be 6, so this is 4 times 6 plus y is 2, so that's 3 times 2. So I'm going to get 6 4s are 24 plus 6, which is 30. So 6 2 will give me 30 when I substitute into my function representing the satisfied region. When it's b, 634, what will I get? X is 6, so this is 4 times 6 plus 3 times 34. That's 24 plus 102. And 24 plus 102 will give me 126. That's B. And C is 3010. So I'm going to substitute 3010 into my expression for P. So this is 4 times X, which is 30, plus 3 times Y, which is 10. So I'm going to get 120 plus 30, which is 150. Good? So which pair of values makes P maximum? Clearly, which pair makes P maximum? 30, 10. So therefore, C 30, 10 makes P maximum. Alright? So this is linear programming, and businesses use linear programming to help to determine if their business makes a maximum profit or not. Yeah? Or what's the maximum profit, or if the profit was minimum, good? Minimal. So they will use linear programming to help in that regard. So you're working within what are called conditions or constraints. Those constraints can be represented as inequalities. The inequalities are then placed on a graph. You look for the satisfied region. That's where all inequalities coexist. Yeah, they're all satisfied in that region. That region in this case is in the shape of a triangle. What you do is you use the vertices of that satisfied region to help you to determine if you can make a maximum or minimum, or determine what's a maximum or minimum value. Right? If it's profit, maximum or minimum profit. Yeah? And how do you do so? You're given an expression, and you're going to take the coordinates of your vertices and you substitute into that expression to determine what is your maximum or minimum value. In this case, you want the maximum value. So the maximum value is 150, and C allow that to happen, 30, 10. Alright? So this is a question here on linear programming we know we need to be conscious of. And I'm going to do one where, alright, where we have to actually draw the graph. So this is one where the graph is given, and all you have to do is get the inequalities from it. But let's look at this one where you have to draw the graph. Alright? So let me get this one here. Alright, I think this is it. Let me see. Right, so what we all see, this is 1, 2, 3, 4, 5, 6. This is 0, 1, 2, 3, 4, 5, 6. Good? Now the question says, using a ruler, draw the lines x equal to a half So these are the reference lines, y equal to x and x plus y equal to 5 on the grid below. You have to draw those lines. And then on the grid, label the region R where you have three inequalities. So you have three lines. So let's make sure when it comes to drawing inequalities, and I'll write three inequalities on the board so you'll see what the three inequalities are. So the three inequalities are x is greater than or equal to a half, y is greater than or equal to x, and you have x plus y is less than or equal to 5. Those are three inequalities. You want to represent those inequalities on a graph. Remember, the inequalities are identified by shading the region. But you need reference lines. You need those lines first and you shade from the lines. The lines are represented by equations. This is why I told you, using a ruler, draw lines x equal to a half, y equal to x, x plus y equal to 5. So, let's start with this inequality. X is greater than or equal to a half. For me to draw that inequality, I need to first draw the line. X equal to a half. The line is represented by an equation. X equal to a half. Where is x equal to a half? X equal to a half will be, this is 0, this is 1, this is a half, 0.5. Halfway between 0 and 1. So x equal to a half will be a vertical line passing through a half on the x-axis. That's x equal to a half there. Good? So let me draw a vertical line. That there is x equal to a half. Good? But then the inequality is x greater than or equal to a half. So where am I going to shade? I'm going to shade to the right of that line. Vertical line greater than or equal to, I shade to the right. That's the inequality x is greater than or equal to a half. So get the reference line first, and then the inequality is recognized by shading. Good? Now the next is y is greater than or equal to x. Now, we need to first, that's an inequality, but you need to get the equation of the line first. You need to get that line first, represented by an equation, the equation of the line, then you shade from that line to represent the inequality. So we have the equation y equal to x. So you need to draw that a line representing y equal to x. You have to be very careful with y equal to x, right? Now y equal to x is of the form y equal to mx plus c. This line wouldn't be a vertical or will it be a horizontal line. Nor will it be a horizontal line, right? This line will be a sloping line because it is of the form what? Y equal to mx plus c. Good? So it's going to be sloping. M is your gradient, which means it's going to slope. C is the y-intercept. But look at it here. Y equal to x. I think we did this when we were looking at transformations. You look at one of this line here. y equal to x, and if you have to draw it, y equal to x, remember, 1 is the gradient, so it's going to be a right hand slope because the gradient is positive, but the y-intercept is what? 0. So this line will be passing through the origin. Keep that in mind, eh? So when it's a line where the y-intercept is 0, it's going to pass through the origin. Keep that in mind. This is passing through the origin and not cutting the y-axis or the x-axis. It's passing through the what? Origin. To draw that line, this is what you do. So if it's a line y equal to x, or it's a line where the y-intercept is 0, this is how you draw the line. Alright, this is how you draw the line. So just set up a table. A nice neat little table. You have the x coordinates, y coordinates. Take all the x coordinates you have there. Start at 0, then 1, then 2, 3, 4, 5, 6. You can take all that you have there. Good? And this is all you're going to do. When x is 0, replace x with 0 in the equation, y is what? 0. So this is why I'm going to pass through the origin. But when x is 1, replace x with 1, y is 1. So when x is 1, y is 1. But second point. So you see, you expect for the line y equal to x, it's going to look like this. It's going to pass through the origin, a sloping line passing through the origin. This is y equal to x. When we looked at transformations day 3, right? We have to draw a reflection about the line y equal to x. That's how it's going to look. Yeah? When x is 2, replace x with 2, y is 2. So you're going to get 2, 2. When x is 3, replace x with 3. You're going to get what? 3, 3. When x is 4, replace x with 4, y is 4. You're going to get 4, 4. When x is 5, replace y with 5. You're going to get 5, 5. And when x is 6, replace x with 6. You're going to get y as what? 6. You're going to get 6, 6. Alright? And now we can draw our line y equal to x. So when it comes to the line and inequality y is greater than or equal to x, or an inequality which is up before y equal to mx plus c, but the y-intercept is 0. It is passing through the origin. To draw that line doesn't cut the y-axis, nor does it cut the x-axis. It's passing through the origin. So to draw that line, just set up a table like this. Take all the x coordinates and substitute it into your function. Sometimes you might see an inequality looking like this too. Y is greater than or equal to say 2x. That's the same thing. Gradient positive 2, y-intercept 0. So you do the same thing. So you know your equation is y equal to 2x. So when x is 0, you're going to get 2 by 0 is 0. When x is 1, 1 by 2 is 2, so you plug it 0.12. Whereas 2, 4, you plug those and you're going to see it's going to be a straight line starting at the origin as a right hand slope. Right? So once the y-intercept is 0, this is what you do. And this is the line you're going to get. Alright, that's the line you're going to get. So that is the line y equal to x passing through the origin. Alright? But then after we have found the reference line, what we need to do, we need to shade. This is what? Y is greater than or equal to x. So I need to shade where? I need to shade above the line. This is a sloping line, and if it's greater than the shade above, so looking at this. Let's put some red mark. Alright, put some black here. Alright? So shade above the line. Okay? So that is y is greater than or equal to x. Now let's look at the last line. X plus y is equal to 5. X plus y. So we have the last inequality. This inequality here. X plus y is less than or equal to 5. Good? Remember, you have to, I'll always advise this. Good? This is very important. Anytime, if you look, this is of the form y equal to mx plus c also. Yeah? That's y equal to mx plus c also. So what I would always advise, always make y the subject of the inequality first. Then pull the equation from it. Make sure it's in this form, y equal to mx plus c. So right now, y is not the subject, so let's make y the subject. So I'm going to write this as what? Y is less than or equal to 5 minus x. Okay? So always make y the subject. Make sure it's in that form. Yeah? So I bring positive x over as negative x, making y the subject. So the equation then will be y is equal to 5 minus x. So that line I need to draw first. That sloping line I need to draw first. And if you want to write it like this, you know y equal to mx plus c. You know the mx is always in front and the c last. If you want to write it as y is less than or equal to minus x plus 5, no problem. Put the minus x in front and the 5 after, no problem. And if you want to draw the equation as y is equal to negative x plus 5, no problem. Just put the negative x in front, 5 after. What this will tell us, because we have a negative sign in front of x, the gradient is negative, so you expect when you draw that line to be a what? A left-hand slope. Alright? So, make y the subject of the inequality first, then pull from it the equation. Okay? Now to draw any line where the y-intercept is not 0, this is the one where the y-intercept is not 0. All you need are 2 points. Yeah? So when it's a case where the y-intercept is not 0, if it's 0, you have to carry out this. Alright? Draw a nice little table, set up this, and draw your line. If the y-intercept is not 0, in this case the y-intercept is 5, all you need are 2 points. These are the 2 points you need. You need your x-intercept where the line cuts the x-axis and the y-intercept where the line cuts the y-axis. That's all you need. So you simply need your x-intercept so you don't need a bunch of points, just 2 points. The x-intercept, so where the line cuts the x-axis, and the y-intercept, where the line cuts the y-axis. That's all they need, and then they have to connect those 2 points. So what is the x-intercept to draw this line? You know when a line met the x-axis, we saw that when we looked at the coordinate geometry questions a short while ago. When the line cuts the x-axis, remember this, a line cuts the x-axis, you know what? Y will automatically be 0 and x will have some value. Not so? So for the x-intercept, we know when y is 0, so let's look at this nice little table here, x and y intercept, just 2 points I need. So I'm getting both points here. So when a line cuts the x-axis, the x-axis, sorry, we call the x-intercept, the y coordinate is automatically 0. So how am I going to get the x coordinate? Yeah? So I can get my x value and y 0. Simple. I'm going to take the equation of the line I need to draw, and I'm going to replace y in this equation with 0. And now let me go solve to find what x is equal to. So to solve that equation, I'm going to take negative x and bring it over on the left hand side. X is 5. So you know what will be the coordinates of the y-intercept? The coordinates of the x-intercept, sorry, is going to be x is 5, y is 0. So I know when I'm drawing this line, y equal to minus x plus 5, the x-intercept will be this. It's going to be the x-axis at 5. This is the x-intercept here. So that's the x-intercept. And now let's find what's the y-intercept. Alright, so the y-intercept is straightforward. It's going to be 5. That's C. Yeah? But let's write it in terms of coordinates. You know when a line cuts the y-axis, you know automatically x is 0 and you need to find y. Good? So we're going to use the same approach. So when x is equal to 0, you know the x coordinate is 0, I'm going to take the equation of the line y is equal to negative x plus 5. I'm going to replace x in that equation with 0 so I can work out what is the y coordinate. This is y is equal to negative 0 plus 5. Negative 0 is the same as 0, so I'm going to get y is equal to 5. So the coordinates of the y-intercept is 0, 5. And where is 0, 5? 0, 5 is here on the y-axis. Wow. Yeah? So all I have to do to draw this line, negative x plus 5, I'm going to connect those 2 points. So anytime you have to draw a line which is of the form y equal to mx plus c, but the y-intercept is not 0, all you need are 2 points, the x-intercept and the y-intercept. That's all. Alright? And to get the x-intercept, you know when a line cuts the x-axis, the y-coordinate is 0, so when y is 0, you just substitute y equal to 0 into the equation of the line. Replace y with 0, bring negative x over as positive x, and get x as 5. So 5 is 0. So 5 0 is of course there. And then for the y-intercept, when a line meets the y-axis, you know the x coordinate is 0. So when x is 0, you take x equal to 0, substitute it into the equation of the line you have to draw. Replace the x with 0 inside there, and you're going to get y with 5. So you're going to get 0, 5 as the y-intercept. And now let's connect those 2 points. So this is my line, that is my line, which is y is equal to minus x plus 5. A left-hand slope. But remember, the inequality is what? The inequality is less than or equal to, less than or equal to. So, where is less than or equal to? Less than or equal to means I'm going to shade where? If it's a left-hand slope, less than or equal to means I shade below the line. So let me shade below the line. Alright, so this is me shading below the line. Alright? And hence, label a region R where all three are satisfied, where all three inequalities satisfied, where all three inequalities coexist here within that triangle. Good? And that would be my region R. That's where all three exist. That's a satisfied region. And of course, you can use that region to help you to determine what is the vertices of that region, to help you to determine what is the maximum or minimum value. They'll give you some expression you have to create, and you use that expression along with the vertices to help you to determine what's the maximum or minimum value. Alright? So this here is a linear programming question. Keep it in mind, when you have an inequality of the form y equal to mx plus c, always make sure y is the subject first. Then create the equation from it. Alright? Okay, so wow, it's 1 o'clock. Alright, so I think I'm gonna end now. Right? I mean, there are others I wanted to look at, but yeah, it's really neat. Good? So so I just want to wish everyone all the best in your exam tomorrow. Go in the exam with confidence, do an excellent paper. Make sure you read your questions carefully. Make sure you show all your working. That is important. Show all your steps. Don't leave out any steps at all. Make sure your steps are properly shown and identified, because you do get marks for your steps. Again, the latter part of the paper is the part of the paper where students often have challenges. So make sure you look at your circle theorems, your bearings, ensure that you can answer those questions well, along with your matrices, vectors, transformations. Once you answer those questions well, it's going to put you in a very good position to pass the exam, because many of you, like I said, will do well in the early part of the paper, but you see from questions 8 onwards, this is where we sometimes make mistakes and cost us, right? It cost us valuable marks. So make sure your circle theorems, which you will see for sure, your bearings, right, which will involve sine rule, cosine rule, make sure you can answer those well. Your matrices, vectors, transformations, make sure you can do that well. Of course, you may see a bit of quadratics, you may see a linear programming, right? The only thing, I want to look at a distance time, but I'm really out of it. Yeah. So what we will do, what I wanted to do is to ensure that you, if possible, right, if you can do the latter part of the paper, do those questions. Look at those questions first, and if they're easy enough to do, that is questions 9 and 10 in particular, I will advise that to do that first and get that out of the way quickly. Alright, and then you deal with questions 1 come up, because you know that you often do well in the early part of the paper. So if you look at the latter part of the paper and it's reasonable enough, you think you can do it and do it well and quickly, get it done quickly, and then just tackle question 1 come up. Yeah? Okay? Or if not, you start with the question 1 come up, and if you recognize it's straightforward, and you completed questions 1 to say 8 quickly, right? Then you will have that time to spend getting 9 and 10 done properly, right? Trying to acquire as many marks as possible to put you in a good position to go get your distinction. Alright? So say a prayer, make sure you ask for that divine guidance, and you go in the exam with confidence tomorrow, and I expect to hear ones. That's what we're aiming for, right? So let that be in the back of your mind. All ones. So we're working towards achieving that, alright? So I'm going to end the session now, and have a successful exam tomorrow. Right? Stay blessed, everyone. Take care.